Howdy, everybody. Or young. Hey. Mm-hmm. I want to double check that I'm actually live horizontally. Okay, yeah, we are. Good. Good. Everybody's having a good day. I know it is Tuesday or Wednesday, whatever day it is. Gotta connect the TikTok live to the TikTok chat because for some reason it's not working. Okay, TikTok chat is connected. Cool. Howdy, everybody. Hope everybody's having a good day. Let's answer some questions, shall we? Are you asking for believers only? No, this is just a Q&A session. Just Q&A. Do you think we live in a black hole? I don't. How elements came from helium and hydrogen? Well, if you take, well, when a mommy element and a daddy element love each other very much, they come together, the center of a star, and they become one element. Nuclear fusion is what I'm describing. And we ask a question if we were atheists. You can ask a question regardless of who you are. What speaks against the singularity from which Big banged? Well, the singularities are generally a sign of the mathematics of the model breaking down, not a sign of something physical. We know that our models are going to break down earlier, or rather later, than the singularity would have happened at, so we have no reason to trust our models that get us all the way back to singularity. You charge your phone using a temperature difference of campfire and a river. I guess in principle, but you would need to build the electronic circuit that would do that. What's your favorite moon? I like the moon. Is there anything beyond the CMB? Yeah, there would be plenty. There would be things like the cosmic neutrino background, for example. Thoughts on the new electrostatic propulsion system? I don't buy it. Why the Planck length is the smallest possible distance? Well, it's not. It's likely not the smallest possible distance, but it might be like a practical limit insofar as if you try to measure anything smaller than that, you'd create a black hole and you would obstruct whatever you were trying to measure. Can you explain how dark energy is woven into the fabric of space itself? We don't know that it is. It might be if it's a cosmological constant, but it might not be if it's some fundamental field. Does energy need to be conserved for a universal wave function? It's a good question. Perhaps that, so it might be the case that energy needs it might be the case that you might need to have a Hamiltonian for a universal wave function without it being properly called energy. It's a deep question though. Why do you think you can't figure out flat Earth is severe mind control? What? Do you think that time is an emergent property? It could be. I'm sort of on the fence about it. How does temperature emerge from atoms? So temperature is just a way of measuring the average kinetic energy of a whole bunch of atoms. So a single atom, the average kinetic energy is just the kinetic energy. But if you have a whole bunch of atoms, then there's a useful quantity that is related to the average kinetic energy. That's all. Do you think life could have evolved out there to have natural jet biology for propulsion? Octopus and some other cephalopods already have this. So yes. Does the moon have an actual planetary name outside of just Moon or Luna? No, it's just Luna. Can the weak plasma that is the ionosphere be held in place by the Earth's magnetic field? Well, in some sense it is, but also gravity, of course. Why didn't we name the moon? We named the sun Sol, the moon just got a title. Luna. Luna's the name. From Mini Edits with the $5. Thank you so much, Mini Edits. I appreciate it. Do you think Schrodinger's cat, quantum immortality, is flawed wrong? Well, so those are two separate ideas. Schrodinger's cat was merely meant to explain kind of how absurd the Copenhagen interpretation was at the time. However, starting in the 70s and 80s, I suppose, this idea of decoherence came out, which kind of resolved the problem of Schrodinger's cat anyway, namely that if you have a macroscopic thing that is even at all in contact with the outside environment, like via, it's emitting photons, and so emitting photons will allow it to interact with the environment, for example, then the quantum state will decohere, and you'll end up with probabilistic classical states rather than kind of superposition of quantum states. As far as quantum immortality, if the many worlds interpretation is correct, then quantum immortality just implies that, even if you die in one branch, that doesn't mean that you die in another branch. That's all fine and dandy, except you are not the one that dies in one branch. You are not the one that doesn't die in the other branch. You are the one that gives rise to both. And so presumably, if you, in the same way that you care about, if there's only one branch of reality, you care about preserving that one branch, your life in that one branch. If there are many branches, presumably you care about preserving all of the branches. So, there's to say that it would be you. Well, no, you would just as much die as you would live, right? In the many worlds interpretation. What was before the Big Bang? We don't know. How strong would gravity be of an Earth-sized black hole? Earth-sized? Like the radius of the black hole is the same as the radius of the Earth? Very, very big. Like enormous. Much bigger than the gravity of the sun. It's something like 1,000 Earths fit in the sun. That doesn't help us. The Earth is something like 8,000 miles across. So it would have a mass that is something like 2,500 times the mass of the sun. So it would be enormous. Enormous gravity. What's the difference between conformal cyclic cosmology and big bounce? In conformal cyclic cosmology, the universe never recontracts. From Lycon with the 2,000 yen, very generous, thank you. Jokes aside, do you think it's possible that an eternal past can lead to an infinite chain of causation via the time slowing down progressively in the past until essentially frozen? Infinite temporal past but finite chain? Well, I don't see why time would slow down. Unless you can provide a mechanism for that, I don't see why that would happen. Why is the speed of light different in different mediums? Because when light is traveling in a medium, it's no longer light. It's an electromagnetic disturbance that's propagating alongside an electron disturbance. Why are you still an atheist if you've been debunked many times? Well, because I haven't been debunked many times, that's why. Do you think we can ever know what was before the Big Bang? Yeah, I think so. I think it's in principle possible. Why was the gas cloud that formed our solar system have so much angular momentum in the same direction that led to orbits? Everything has angular momentum to some degree. And so it's not that it had so much, it's just that it had some. And having angular momentum means that you have a tendency to produce disks. What is the weak force? The weak force is kind of two separate things that are bundled together. I mean, they're two separate pieces of the same thing. One is just like a very much weaker version, very much shorter range version of electromagnetism. So there's something called weak hypercharge. And if something has weak hypercharge, positive or negative, then it can attract or it can repel in the same way that electromagnetism can, except it acts over much, much shorter distances. And the strength of the force is much, much weaker over longer distances. Then there's the W and Z bosons, which are kind of, these are called flavor-changing charge currents? Anyway, these are flavor-changing currents, which, because the W and Z bosons have charge themselves, these are the force carriers for that part of the weak force. Because they have charge themselves, they can't preserve the kind of particle when they're emitted. So if you have an electron, or say a muon, that emits a W minus boson, for example, a muon is negatively charged. It emits a W minus boson, which is also negatively charged. That means that the thing that's left behind has to be neutral, say. And it can't be neutral, and so it can't be a muon anymore because muons are negatively charged. So it has to change the kind of particle it is. So the W boson can change the kind of particle, but it's still a force in the sense of there's a gauge boson that's involved. How do quantum fields interact? What causes an excitation? Well, look, so it just seems like they're different quantum fields and they talk to each other in different ways. We don't know why that's the case. That's just a thing that they do. If the universe is indefinitely expanding, what is it expanding into? Is there an endpoint? So the universe is not expanding in the way that you think it is, where there's like an edge and the edges are getting further away from each other. It's expanding in the sense that like stuff inside is getting further away from other stuff inside. So it's not really expanding into anything. There is nothing outside the universe as far as we can tell. From Lycon with 200 yen, gravity, expansion, scalar fields, fixed points. Not really a question. From Christopher Sanford with £5. Hey Blitz, why do you still sleep on the upper level of staked beds if you've been debunked so many times? Good point. Yeah, I should not be sleeping in bunks anymore. I should be sleeping on the lower level of staked beds. You got me. What's the difference between relativity and physics? Relativity is a theory it's like kind of an idea. It's a concept that is part of physics. Do you believe life is deterministic? In a certain sense. If something moves fast, there's time dilation, right? But what will happen with time from the object perspective if the object is near absolute zero? Nothing. Temperature doesn't really affect time dilation except at extreme temperatures, where you can have like very, very hot things will have some sort of time dilation that reduces their radioactive decay rate, for example. From Lycon with the 200 yen, or 200 yen, it was a reply to your question to my super chat. Gravity, expansion, scalar fields, and fixed points. None of those would really help slow down time. Because the thing is that time is never slowed down relative to itself. Time is slowed down, or time is never slowed down for the observer that's experiencing the slowed down time. It's only relative to somebody else. But if it's happening everywhere in the universe, then the time isn't slowing down at all. Is that why acceleration increases as space in between gets larger? Yeah, roughly. Mr. Physicist, I have a question. How likely is the possibility of a previously undiscovered natural entropy lowering phenomenon? Doesn't seem very likely. Also, that's Dr. Physicist to you. Why can't we use the gravity, or let's say the moon, as an energy source? I may be stupid. So we can use gravity as an energy source. The only trouble is that once you use it, in order to use it again, you have to bring something up. But in some sense, hydroelectric dams use gravity as an energy source, right? And the key is that the water cycle is the one that's bringing the water back up to the top, and then we let it fall down and we get energy from it. Similarly, the moon, we could in principle extract energy from the tides. The trouble is that would involve oceans, and oceans are really corrosive. From the Physicist 70 KPC with $5, which books would you recommend for someone with a physics background looking to get back into it as a hobby? Probably Sean Carroll's The Biggest Ideas in the Universe. Will we ever reach 10 to the 19 GeV energy and particle accelerators? I suspect not. At what point in a core collapse supernova do neutrinos shift from just escaping the star to actually becoming the main driving force behind the expansion? If there's going to be a core collapse supernova at all, then it's basically immediate. The neutrinos are emitted, the collapse has stalled, collapse is coming in, collapse stalls, but neutrinos are emitted. Neutrinos push back out, re-energize the collapse, and they cause it to go out. So it's pretty immediate. From Lycon with the 1,000 yen again, thank you so much, Lycon. It's always good to see you. Gotcha, thank you. But then how do we get a finite chain of causation? Also, thanks for getting me back into science and religion debates. I don't know why you need a finite chain of causation. At what point when you get something super hot does the physics get weird in general? It depends on what you mean by weird. So plasma physics starts happening at a few thousand degrees Celsius, depending on the stuff. But that's not so weird. You know, a few trillion Celsius is when you start to get quark gluon plasmas, which is that's weird. Is this debate or office hours? It's office hours. How much of Einstein's theories were proven or disproven? Basically all of them were proven. Could we live on a flat Earth? No. Can you explain why the universe started out in a special low entropy state at the beginning of the Big Bang? I'm not convinced that it did start out that way. Wait, time doesn't exist at the Planck scale? Is that more of a gap in our understanding of the one? Who said that time doesn't exist at the Planck scale? Who said that? I didn't say that. At what point? Oh, okay. I'm going to jump down to the bottom because I'm a bit behind, but apologies. Why slow instead of fast-moving neutrons are needed for fission of uranium? Because they're easier to be captured. Think of it this way. It's easier to catch a baseball if it's moving slowly. Something like that. From mini edits with the $5, what's your opinion on people thinking CERN is altering realities and quote of the day? I don't have a quote of the day, but my opinion of people thinking CERN is altering reality is that they should just actually learn about what CERN does. What's the last interesting thing you learned in physics? Last interesting thing I learned in physics? I learned about this thing called quantum mereology, which was neat. I made a video about it, so you should go watch it because it's kind of neat. It's funny this dude thinks he's smart yet denies the deity of Christ, IQ of 0. Oh, okay, well, I guess that means Einstein also was IQ of 0 because he also did the same. Why are all liberals prescribed antidepressants? I don't think they are. Do you think we live in a simulation? No. What is the airspeed velocity of an unladen swallow? African or European? Is the speed of light actually infinite and limited by the speed of causation? No. If it was limited, then it's not infinite, right? You ever just tried to break a concept illegally for fun? I don't know what that means. What do you mean break a concept? It's just hard to wrap my head around an infinite past, kind of like Achilles and the turtle. I know it's just an analogy. I know it's the only possible explanation or one of the few, but oh, okay, that's fair. How's the black holes weren't proven until that pic a few years back? Well, in some sense they were proven. It's just we didn't have a picture. That's all. Is there a temperature where all neutrons and protons would fission from the atom? Would fission? Yeah, like a few trillion degrees. Yo, as an atheist, what do you think happened, or was there before the Big Bang? I don't know if there was before the Big Bang. I don't know what caused the Big Bang. I think that we don't have enough information. Is light's movement linked to the direction of time since we only observe photons traveling towards us? Well, we only observe photons traveling towards us because that's the direction that photons are traveling in if they're going to get to your eyeballs. But like, we know that photons can travel away from us. Could stuff smaller than the Planck scale exist? How does that tie into the argument whether or not the universe is continuous discrete? Yeah, in principle stuff could. It would just be forever out of our reach, out of our observational reach. How do you feel about the fields of biochemistry and molecular biology? I don't have feelings about them. I don't really know anything about them. What do you think about living in a simulation? I think it's nonsense. Is there anything in the universe that is absolutely still not moving relative to the fabric of space? There's no such thing as not moving relative to the fabric of space, because relativity says that you can't tell the difference between moving and not moving if you're just in empty space. What is your current area of research in mathematical physics? So I generally study lots of things. If it has to do with gravity, I'm interested in it generally. But also I do some mathematics, some pure mathematics on the side. So. What physics field do you recommend the average person to get into in uni? when you're at university, you're not going to be specializing at all, so don't worry about picking a field yet. The vacuum of space has infinite potential energy. Is empty space heavier than all physical matter? It doesn't have infinite potential energy. Do you think science is currently too focused on mathematics? After all, mathematical proof does not equate physical proof. What's your opinion? Well, look, mathematics is a language. It's just a way of coming to rigorous deductions about like given hypotheses. So no, I don't think it's currently too focused on mathematics. If you have a mathematical proof and the hypotheses, if you have mathematical proof about some physical thing, and the hypotheses in that mathematical proof are satisfied, then it follows that the conclusion must be satisfied. Why is wave-particle duality so counterintuitive? Is that just me? Well, because it's not really real. All of it is waves, it's just some of those waves are more particle-like than others. Is Hawking radiation one of the particles that are made will go inside the black hole, then that is more energy going in? No. Is it that the energy is taken to make the particles needed to be reset? No. So in the virtual particle explanation of Hawking radiation, the particle that is inside the black hole has negative energy. And the reason why you can see this is because if you're on the other side of the event horizon, if you're inside the black hole, space and time swap. And so the energy that it has can be negative, even if usually outside of an event horizon, the particle would have had positive energy. Once it falls into the event horizon, it can have negative energy. Is relativity something that humans created to understand physics relative to ourselves? No. Well, I mean, okay, yes, in some sense. But in some sense, it was a discovery. Can you explain Einstein's field theory? Do you mean Einstein's field equations? So Einstein's field equations, which are the core of general relativity, is that the curvature of spacetime is proportional to something called the Ricci curvature of spacetime in particular. Okay, one more time. The Einstein tensor, which is related to the Ricci curvature and the scalar curvature, those two things combined are in some sense directly proportional to the matter content of the universe. Do you think it's possible our universe exists in a black hole? Possible, sure. Likely, no. Why do mirrors portray a 3D image despite being described as light bouncing off a surface? Shouldn't that just create a distorted image? Why does it create an actual mirror image? Well, it creates a mirror image, which is two-dimensional, not three-dimensional. Are you uncomfortable with a particular theory of physics within physics? If so, which one? No, not really. I'm way behind, sorry. I have to jump down to the bottom. Does science make you lean towards any type of creation or no intelligent cause? I don't know if it's science that does it, but I don't think that there's any kind of creation. It's just not my day. I don't think I slept enough. Pre-recorded. No, it's not. I was just behind. Who do you think gets the top slot in the smartest people of the 1900s? Gotta be von Neumann. Why would something theoretically smaller than the Planck scale be unreachable for study? Because if you tried to study it, you'd have to probe, you'd have to dump enough energy. Like, okay, let me back up. The way that we study small things is we basically make really, really energetic particles, and then we smash them into things. And that lets us probe smaller and smaller scales, smaller and smaller details. But if you want to probe scales smaller than the Planck scale, you would need to produce so much energy that the things would produce a black hole. And so whatever you were trying to probe would be caught in the black hole, and you wouldn't be able to study what was going on. What do you think of the principle of maximum entropy as a cause of life? It seems plausible, yeah. From Juice Mian with the do you think the expansion of galaxy that it will eventually expand to a point where it's so thin it couldn't support life as we know it? Think water with no surface tension. The galaxy isn't expanding, and as far as we can tell, the expansion of the universe isn't increasing such that it would cause the galaxy to expand in the future. So no, that's not a thing that would ever happen given our current data. I have a Viva tomorrow on the diffraction grading. Could you explain how the image would change based on how many slits are in this experimental setup? You mean like the image on the back of the screen. So all you have to do to figure out what the image is you basically have to do a sum of cosines that are at different phases. And those phases will depend on where you are along the screen. Surely you must have learned this in class, right? I mean, I can show you some lecture notes, but is it this course? Yeah, here you go. But surely you learned this, so this shouldn't be new. So this is single slit diffraction. Oh no, sorry, this is the wrong set of notes. Probably lecture 9, maybe lecture 7. Then film. No, okay, maybe it's lecture 7. Yeah, okay, so it's this. The relevant phase difference is d sine theta going up in each term. And so all you have to do is add up the intensity from each one, including the phase. Hopefully you can see this. And what you'll find that there's a intensity spectrum that changes with the angle from the slits. And so you can end up with something like this. Now it's really a pain to do this, to actually derive this. There's a lot of trig involved, but it's doable. And that's, I imagine that's something that you should have learned if you have a Viva on it soon. I like to think of the next step for gravity after black hole universe is infinite so bigger. I don't understand the question. What are these dark matter and dark energy I keep hearing about? Dark matter is just a kind of matter that we can't see. Dark energy is whatever is driving the accelerated expansion of our universe. Grown man out here doing fractions. Fractions? I guess technically these are fractions, yeah. I would probably call them ratios, but yeah, that's part of mathematics. If the universe is deterministic, does free will exist? Not in the libertarian sense. In your POV, do you think that the universe itself is oscillating like a fundamental oscillator? I meant expanding and crunching. Not necessarily, but I think it's possible. From Matt Swenson with the $5, starting from 0, what math would be needed to solve Einstein field equations? Calculus, differential equations, partial differential equations, linear algebra, differential geometry. That's it. And then everything before calculus, like algebra and all of that stuff. Spinoza and Einstein were Christians. Just drop the debate already. You think Spinoza and Einstein were Christians? They were literally Jews. Both of them were literally Jewish. And neither of them believed in theism. Do you think mankind will create teletransportation? No, I don't think so. Is it true that Michelson morally experimentally actually proved a specific theory of the ether failed? Not that the ether itself was wrong. They basically showed that the one remaining, not yet disproved theory of the ether was false. How much chemistry is there in physics, and do you use any chemistry concepts? I don't use any. And I mean, it depends on what branch of physics you use, but not a lot of physicists use any chemistry. Do you have any scientific researchers in terms of physics? Yeah, you can go to my website. My website has all of my publications on it. This is a perfect time to show you guys my website, which, you know, it's been live for a while. It's just blitz.phd, which is a pretty great URL if I do say so myself. Oh, that's not the right window. Here we go. It's just blitz.phd. Pretty easy to get to, so you should check it out if you're interested. But importantly, there's a research tab. You can go and you can look at all the papers that are published. You can also, you know, read a blurb. All these papers are publications that I have. And I think literally all of them are freely available as well. You could just go read them. Now, the versions that are freely available are usually the preprint versions, and sometimes slight changes are made in the published version, but Their use in learning deep hyperbolic geometry from math relativity. Sorry for repeating. I don't know what you mean by deep hyperbolic geometry. Hyperbolic geometry can be quite useful though. If atoms are 99.9% energy, then what is even reality then? Where did all that energy come from? Atoms aren't 99.9% energy. I don't even know what that means. Does Dr. Blitz even read YouTube chat? Yeah, I do. What are we talking about? Was that end-slit diffraction or something? It was, yeah. Do you use calculus or not? Absolutely. Dr. Blitz, why did NASA lie and say they went to outer space when space don't exist? How come Earth photos are CGI? Oh, they are they? They are they? Is this a joke to you? Is this a joke to you? This existed before CGI existed in any sort of reasonable capacity. I'm way behind again, sorry. When did you receive your PhD? June of 2022. Did we ever actually prove atoms exist, or did we only prove they might exist under our current framework? Yeah, we did. We can see them directly with scanning tunneling electron microscopes. Let me show you. Very neat. These are direct images of atoms. And in fact, we can do even better than that. There's something called electron ptychography, which I can never pronounce. Starts with PTY. Here's another. These are images of actual atoms, individual atoms, right? So like, yeah, we definitely do know that atoms exist. Is it theoretically possible to send information to the past or the future? Well, sending it to the future is really easy. You just take your message, write it down, put it in a time capsule, and then tell everybody to not open it until the future has arrived. Sending it to the past is probably impossible. How would you recommend one studies gets better at maths for their master's studies? Practice. It's a skill like anything else. You have to practice it. What papers have you published that you found later on you had to retract, and how come it happened? I haven't had to retract any papers. I did publish an errata for my first paper, or actually we submitted an errata for my first paper. The paper was like morally right, but there was one result that was strictly false as described, so we fixed it and we uploaded an errata. And that's currently with the editors. But there haven't been any other retracted papers. Haven't been any retracted papers, actually. Jumping down to the bottom again, because you guys are asking a lot of questions, which I do appreciate, by the way. Why is there no conservation of energy on a global level? Because on a global level, our universe doesn't obey time translation invariance, and if time translation invariance doesn't exist, then Noether's theorem implies that there is no such thing as energy conservation. Would you ever become a professor? I am becoming less and less certain that that's what I want. There was a time when that was my ultimate goal, but in the last few years, because of the AI stuff, it seems like, and like academia seems like it's getting much, much more insufferable. How many hours did you study when taking a PhD? I don't even know how to answer that question. It's not like a class that you study for. Do you know who are the best researchers for gauge gravity? The best researchers? There's a lot. I don't think there's probably not a best. If simulation theory was real, wouldn't that be conceptually pretty similar to there being a god? Not really, no. Dark matter doesn't mean that we cannot see it. Does it mean that we cannot see is that it doesn't interact with electromagnetic field? Yes, that's what it means. Are physics YouTube channels, any physics YouTube channels you would recommend? Yes, PBS Spacetime is probably the best one that exists, in my view. Is it true that the pictures of black holes we do have are based in rendered images, not necessarily actually images, but instead the translation of vague radio wave signals? Well, yeah, they're formed from radio waves, but I mean, all images from like digital cameras are rendered, right? Like if you have a digital camera, it's rendered. So it's rendered in the same way. Would you ever consider doing a study on lava lamps? Probably not, but somebody should. What are your thoughts on quantum loop? You mean loop quantum gravity? I think it's an interesting idea. I'm not so well read on it that I can have a informed opinion. What would the implications be if we found out that black holes store information? In some sense, we kind of already think that. Don't you mean more certain that it is not what you want? Yes, I guess I do mean that. Did you know Albert Einstein was a real person, not a theoretical physicist? Yes, yes, that's a good joke. Is it possible to convert all of the mass of an atom into energy? Not without having an antimatter atom, I guess. And it doesn't convert it into energy, it would convert it into light in most cases. What is the difference between professor and teacher? Professor is a title at a university. Is an infinite regress of causality possible? And if so, how did we transverse an infinite amount of time to get to the current moment? Yes, it is possible, and there was never an infinite amount of time that was traversed. When you talk about an amount of time, you have to talk about the amount of time between two things. And so if you take two events, there will always be a finite amount of time between them. How many dimensions is the Planck length? Is it best to visualize it as a cube? The Planck length is a length, a one-dimensional length. Favorite niche branch of pure maths and why, and what pure math stuff are you working on? Conformal geometry. That's what I did most of my PhD work in. And it's what I'm still working on. If you go look at my publications, what you'll find is that a lot of them have to do with have the word conformal in the title. See? Einstein and Yang-Mills. This is just a list of the publications. Einstein and Yang-Mills implies conformal Yang-Mills, conformal hypersurface invariance and Bach-type boundary problems, non-existence of higher order conformal fundamental forms in odd dimensions. This is a cosmology paper. This is a black hole paper. This is a black hole paper. This is a quantum gravity paper. Holography of higher codimension submanifolds, Riemannian and conformal. Higher fundamental forms and more product hypersurfaces. That's just some regular Riemannian geometry. This is some more cosmology. This is some more black hole stuff. This is more conformal geometry stuff. This is more conformal geometry stuff. This is more conformal. So, like, I clearly have an interest. Thoughts on eternal recurrence theory? We should stop calling things theories. Like, this is eternal recurrence is just like, it's a concept. It's not a theory. It's a plausible concept, but it's just a concept. Is it possible that a black hole can be the center mass of a star? People have thought about this. These are things called black hole stars, but as far as I know, we haven't detected them. Would it be inaccurate to visualize extremely small spaces as three-dimensional Planck pixels? Yeah, probably, because we have no reason to think that they're pixels, or that they're like the smallest size. Why isn't GR 5-dimensional? XYZ time, then the rate of time-space. It seems the fourth dimension proposed by GR is not the passage of time, but the rate. I don't know what you mean by the rate of time over space. The point is if you're moving through space-time, then you can say how fast are you moving through time relative to how fast you're moving through space, and that's what speed is. Are you a capitalist? I would say probably not. Depends on how you define words, I guess, but generally I call myself a socialist of some kind. Do you believe ancient humans could have been more knowledgeable given what they have built? No. No, they were less knowledgeable. They're still smart, though. What's the likelihood that there's a fifth force? How am I supposed to guess? What if Planck units aren't the right scale for quantum gravity? Then I would be very perplexed. Is all energy and matter fundamentally just different states, configurations of properties in the universe? Yeah, probably, but I wouldn't say that energy is that. I would say matter is that. Nice, now I need to Google what conformal with an L at the end. What did you study? Where did you study bachelor's? I went to Arizona State University. It's just a giant state school. I was in the honors program, but like it's not the greatest school in the world, but it does have a lot of programs. How does Hawking radiation work? Hawking radiation, the best way that I've heard it explained, and you know, my preferred intuition, is that Hawking radiation is just what happens when you have stuff inside the black hole, quantum tunneling outside. There was a recent paper last week about black hole stars which had evidence of detection from JWST. So they were talking about a different kind of thing than what the question asker was talking about. How likely that what we know about outer space is based on optical illusion and not reality? Not likely, because people have been there. What's your opinion on pursuing math PhD when it's obvious math academia will change quite a lot due to LLMs? So this is a hard question. It could be the case that we're in for like a mathematical renaissance, and like the way that we do math is going to change. But like we might see an explosion in the amount of mathematics that's done, which could mean that this is a really, really good time to get in and like familiarize yourself with how LLMs are going to be used in mathematics. In the same way that like it was, 200 years ago, a talented mathematician would be able to do enormous computations and like, take square roots of numbers, and like they were very, very skilled at arithmetic. Now that's not a skill that mathematicians need because we have calculators, we have computers. But now the skills of a mathematician are very different. But we're still doing mathematics. So it could be that with the advent of LLMs being able to do the kinds of things that mathematicians used to do in the last 50 years ago or 10 years ago even, the skills, what makes a mathematician a great mathematician, might change, and figuring that out might be very exciting. The alternative is just that this is the end of mathematics as we know it. So it's really hard to say. "99% of an atom's mass is just binding energy equals mc squared. What is solid matter?" Look, mass and matter are not the same thing. The mass, it is true that 99% of an atom's mass is just binding energy. That's true. That doesn't mean it's not matter. The binding energy contributes to the binding energy contributes to the mass. The matter, whether there's matter there or not, is unrelated to the amount of energy that it has. Do you think physics is a high-paying degree? It depends on what you do. Why do we still believe black holes exist despite the math leading to a singularity? Well, so black holes are just a region of space that's enclosed by an event horizon. Now, we have good reason to think that those exist. The question is just what happens at the middle. What happens inside the event horizon. That's what we don't know. Speaking of Hawking radiation, can you explain virtual particles, A and B particles that come into existence and annihilate each other? They're not real. They're made up. They're hoopla. Hokum. Fabricated. Nonsense. Hogwash. They're not real. They're a mathematical trick. Thoughts on the idea that our universe exists within a black hole based on the recent JWST findings? I don't think any recent JWST findings have implicated that at all. What do you think of challenging the cardinality of the real number line to prevent infinities? I think that that's very silly. Do you think the rate of our ignorance gap getting smaller is receding so much that we have hit a wall at the Big Bang? Or no, I don't think so. We just need better instruments, and then we in principle could see what was before the Big Bang if there indeed was such a thing. Oh. Is there a reason that quarks have fractal charges? It makes no sense to me. It's just a convention. How are specialty unitary groups used in particle physics other than just being a reference for how the matrices they use transform it? It's literally just that. Literally just that. What's the harsh reality about being a math or physics researcher? Finding a permanent job is hard. Like very, very hard. And new ideas are hard to come by. What's a good way to get better at math if you don't find numbers and statistics engaging? I mean, like, to get better at math, you have to practice. That is the reality. It's a skill just like anything else. From Go Get It Lady, do we have evidence of quantum entanglement? We have so much evidence of quantum entanglement. Overwhelming evidence of quantum entanglement, even. So yeah, I mean, like, basically, in 2022, there were awards, there was a Nobel Prize given, not for quantum entanglement, but for experiments that required the existence of quantum entanglement. By the way, just as a pre-warning, I guess, in 45 minutes, I'm going to switch the live over from, so everybody will be able to watch, but I'm going to switch live over to the only people who can send text questions will be people who are super fans or members on YouTube or subscribers on Twitch. So it's $5 a month, and then you can get your questions answered for an hour and a half after the first hour and a half of, everybody asks questions, period. Everybody can watch, but consider becoming a member to help support this channel, help support me, help support what I'm doing, and you get some nice perks, including getting your questions answered specifically twice a week for an hour and a half. You get access to a private Discord channel, you get access to emojis, and you get access to my debate notes, which are fairly helpful. I've found that people like them quite a lot. If you haven't seen them before, it's these. These are the debate notes. And yeah, they have stuff for flat Earth, theism, young Earth, a whole bunch of resources, arguments, and so on. And so some people like that, and that's one of the perks that you get with the membership stuff. And you also get, of course, the question and answer sessions here. So consider that. Just giving you a warning. Let's go back to answering some questions, though. Ask a physicist, ask government. I don't work for the government. I actually work for myself, interestingly enough. You debate theism? Yeah, I do. Once or twice a week. Why do physicists have so much different math notation? As a mathematician, it's so confusing. Tell me about it. I talk to both. I work as a mathematician and I work as a physicist, and I have to change the language and the notation that I use depending on who I'm talking to, which is really frustrating. Why is a potential Carroll structure physically preferable to existing Carolean geometries? It's not preferable. We didn't make any claims about it being preferable or physically preferable or anything like that. It's just a mathematical structure that's perhaps interesting. From Demtra with the $10, can you explain how better instruments could allow us to see what existed before the Big Bang? This seems unlikely from a layman. Honest question, no hate. Yeah, no, this is a good question. And I was kind of alluding to it, but so currently we can't see with a telescope, with an optical telescope, anything, or even like an electromagnetic telescope, anything before 380,000 years after the Big Bang. The cosmic microwave background radiation is basically an opaque obstruction. Now, with neutrinos, with better neutrino detectors, we could in principle see up to about 1 second after the Big Bang. But that's still not enough. However, with better gravitational wave detectors, gravitational waves are not impeded by anything. The universe is never opaque to gravitational waves. So if we had sufficiently sensitive gravitational wave detectors, say out in space with very, very long baseline interferometry, one could in principle detect gravitational waves that would have had their origins before the Big Bang if such things existed. And so, if we could detect such things, that would give us evidence of stuff that existed before the Big Bang. Do you think we will build an accelerator to prove string theory? Not for a long, long time. Tell us what gender is. It's a sociological phenomenon that we use to distinguish between certain roles in society. How much of the proton spin is attributed to the orbital motion of partons? Please hurry. A third. It's a good question, though. Why do you care about debating creationists and such? Who cares if they believe in that stuff? Because they have influence in the world that I live in, unfortunately. Maybe you're not old enough for this, but to remember this, but in the early 2000s, there was a push to put creationism in schools, which would be devastating for our educational system. So, how much programming CS do you do now? Well, now I used to write Python scripts to solve do some simulations and stuff back in the day. Now I just vibe code it because it's so much faster. So I don't really use any anymore. I don't really do it myself because look, I'm not interested in doing the programming myself. It's just a tool to achieve some goal. So of course you have to check the code, make sure that it's doing what you want it to do. But from Demtra with the $2, thank you, great explanation. I appreciate it. Of course, yeah, I'm glad to provide. If the weak nuclear force disappeared, how long would we have? Is the weak nuclear force involved in the sun? I don't think it is. So the main nuclear reaction that happens in the sun is called the proton-proton chain, or the PP chain, which is funny. But the PP chain, I don't actually think it uses. No, it must. It must use the weak nuclear force. So I suppose fusion would stop in the sun. So we'd have 100,000 years, maybe, give give or take, because the sun, most of the energy from the sun takes a while to get out. So even if fusion stopped, well, actually, if fusion stopped at the core of the sun, then the sun would collapse pretty quickly, actually. So we'd have like 8 minutes maybe. Well, okay. The Earth could survive without the sun for a short time, for more than 8 minutes, but it wouldn't be a lot. We wouldn't last long. How many years of education does it take to get a PhD in theoretical physics and/or quantum mechanics? Well, I graduated high school, of course. Then I went to 4 years of undergrad. Then I went straight to a PhD program, which has something like a 2-year master's kind of like added on at the bottom, and then another 3 to 5 years for a PhD after that. Virtual particles don't exist, then how can they destroy a black hole? Well, they don't. Stuff just leaks out of the black hole through quantum tunneling. Do you think a warp drive is realistic to consider? It's interesting to consider, but realistic, I suspect not. Is it at all possible that dark matter isn't real and maybe there exist many black holes that we are unaware of? Dark matter, that would be a kind of dark matter. Is the geometry of null hypersurface sufficient to reconstruct horizon thermodynamics without assuming semi-classical gravity? We don't know. Not clear. But maybe. This was a conjecture that we made at the beginning of one of our papers. Programming is fun, but outlining what the program should do and letting an LLM deal with the syntax is often more fun. So I agree with in certain respects, like solving, like kind of coming up with algorithms is fun. But like, for example, there's a project I'm working on with someone who is in the chat right now, where basically I needed to, like we have a hypothesis and we were basically doing like experimental simulations. And we basically needed to check to see if this kind of method for kind of measuring curvature in a discrete spacetime works. And what that amounts to is I needed to construct a spacetime, simulate dropping down discrete chunks onto that spacetime, and then do a whole bunch of calculations for it. And that's not particularly complicated. Like the actual details are not complicated. It's just coding it up is a pain. So, you know, that's not fun. From Equilibrium with the $5. For your coffee addiction, what's your favorite brew? The blue one? It's the one of those espresso machine things. Whatever's in the blue pod. How much measure theory is used in physics? A quantum mechanics for math students has measure theory as a prereq. Is it spectral measures or something? No, measure theory does show up because, you know, especially if you're doing quantum field theory, there's a lot of measure theory baked in. Just because you're talking about doing integrals over large space, or integrals over perhaps like poorly defined spaces. And so being able to know what the right thing to do is a sensible thing. Do physicists use some knot theory, den surgery, or has it become completely pure math? I haven't seen it, but I shouldn't say that it's not used. Is it possible to create a black hole in a lab and have it be stable and not destroy everything? Not with current tech, no. So the thing is that a black hole is more stable the heavier it is. We don't have enough tech to make a black hole, or we don't have advanced enough tech or a sufficient energy source to make a black hole that would have enough mass to be stable. What do the matrices used in particle physics represent? How many quantities, lone numbers, vectors, matrices, tensors are required to fully represent one particle? How are they assembled? So it's not quite clear what matrices you're referring to. If you're referring to matrix elements, these are matrices in some sense, but they're not matrices in like the sense that you learn in linear algebra. You can think of them as like overlap between quantum states. And you know, in principle, part of the quantum state requires specifying like a momentum, and a momentum is a real number. So, you know, now you could count how many real numbers are involved in specifying like a matrix element or something, and then it just depends on the kind of particle, like what its spin is. That will tell you about what kind of polarization states it can have, what its momentum is. That's of course going to be 4 numbers. What kind of flavor states it might have, what kind of color charge it might have, things like this. So all of these things are going to affect how many, you know, pieces of data you need to specify a particular matrix element for a particular scattering amplitude. From Varys Severin, thank you for the $5, Varys. What would happen if the speed of light increased or decreased? How much would it need to change to make the universe look significantly different? It depends on the way that it's increasing. So the thing is if we only changed the speed of light and nothing else, if all of the unitless constants stayed the same, then the universe would look exactly identical to the way it is now. Things would just be bigger or smaller. Like, it would be just like rescaling the universe. But if you allow the speed of light to change, and so it changes the unitless constants, then that's a very different story. It depends on which ones change. Based on Hail Mary physics, it takes like 23 years accelerating constantly to reach the edge of the universe 43 billion light years away, because dilation is not based on velocity, is based on velocity, not acceleration. Do photons live in a universe with non-space? Photons don't have a reference frame that you can use to refer to how much time it takes or something like that. What about galaxies like MOM Z14 that appear to be more advanced than supposedly possible? Well, they're more advanced than our previously understood galaxy evolution models imply. But that's just because our galaxy evolution models are probably wrong, because they were based on late universe galaxy formation rather than early universe galaxy formation. From Zach M with the $5, do you believe in the big bounce, big crunch theory? Why or why not? Where can I read more about it? I don't believe in it. I don't think it's false. I just don't think that we have enough evidence to say that it's correct right now. Now, that said, this is something that I'm like aesthetically interested by. So like, I'm working on a paper that involves, that's a model similar to this. I'm working on a paper with a few colleagues internationally that, you know, involves this. But it's not something I'm convinced of. It's just, I think, something that's worth investigating. What was the cost of your PhD and how much have you earned professionally as a PhD? So at least in the United States, at least in STEM, you don't pay for a PhD. You apply out of undergrad for a PhD program, and then you get tuition waivers, and you get tuition waivers, and then you're either the professor that you're working with has funding for you, in which case you just get paid to do the research, or they ask you to like be a TA or teach classes, and then you get a stipend from that so that you can, you know, afford to live, and then you don't have to pay any tuition. So it cost me nothing. How much have I earned professionally as a PhD? You mean like in the last 4 years since I finished? So my first position was in Central Europe. I was a postdoc in Central Europe, and I was making around $25,000 a year. But putting that in perspective, the cost of living in that country is significantly lower than what you would expect to make than the cost of living in, you know, a medium-sized city in the US. And so that would be the equivalent. I was living as if I was making around $75,000 a year for 2.5 years. Then I moved back to the States, and I've been doing science communication as my full-time gig because it pays better and I get more freedom this way, and I make more than that. From Nishal Savla with the 20 Indian rupees. Thank you for the donation. I do appreciate that. If black holes are beginnings of a new universe, does that contradict universal expansion? Not necessarily, but also we don't have evidence that they're the beginnings of new universes. How does electricity actually flow in a wire? Is it the electrons or the waves for the energy? Is it the electrons or the waves for the energy? It's both. The electrons are well, okay, it's sort of the waves, but the electrons definitely follow. They're along for the ride. What's the Page-Wooters mechanism in simple terms? Essentially, it's a way of seeing that time can emerge from an otherwise timeless state by having a clock field that's in a superposition of many different states, and then the state that the rest of the system is in is entangled with that clock field so that it's in different states when the clock field is in different states. So it's all already there, but the other matter, if you forget about what the clock field, if you don't know that the clock field is in a superposition, it just looks like the states of matter are evolving as the clock field moves forward. Do you want to go back into academia? In some sense, I'm still in academia. Now, do I work at a university? No. But do I want to work at a university? I'd like to have an affiliation just so I can have the .edu email address, because that makes starting new collaborations easier, but no, not really. How much from TikTok? So from the videos that I make about $10,000 a month, hopefully. from the videos that I make, just from the educational stuff, the educational content. Now that could come and go. I'm part of a program that gives a big boost to educational content creators, but a lot of people have lost access to that recently, so who knows if and when I will lose access to that. At this point, I'm just kind of like banking stuff or I'm just banking cash until that inevitably happens and I have to figure out something else. But yeah, no, it is, I mean, you know, it's a lot of work, right? Producing quality content that gets a lot of views every day is hard, but I'm very lucky that that's my situation right now. And then of course there's like super chats and stuff from live streaming and, you know, ad stuff from like YouTube videos, but that's less. No, YouTube pays like nothing for shorts. Can you do collab with Veritasium or PPS FaceTime? I'd love to. Blockfield is in a super position. I like that. I gotta use that one. Yeah, there you go. Do merch. Look, so I need to do an LLC first, and it's like I'm so busy because like look, this like I do this part-time, like this live streaming, making videos. That takes up like half my day, and then the rest of my day I actually spend doing scientific research. Like I don't just do this full time. And so, because I have like 6 active collaborations with active projects, active science that I'm working on. And I just feel like I have no time. And I have to form an LLC, and then I have to design merch, and there's just a lot to do. It's on my to-do list, I just haven't done it yet. From Matt Lloyd with the £5. Hi, Dr. Blitz. Did you ever read Hitchhiker's Guide to the Galaxy? Is it true you're skeptical of a singularity? Can I get a happy birthday also? Hello, first of all. Sorry, I'm playing with some dice. Hello, first of all. Yes, I have read Hitchhiker's Guide to the Galaxy and all of the sequels. I love those books. Is it true I'm skeptical of a singularity? Yes, I am. And also, happy birthday, Matt Lloyd. And from Adam with the $5, I'm starting to feel I'll never understand virtual particles. Help, please? Virtual particles aren't real. So, okay. The best way, if you have any math background, here's the best way to think about what virtual particles are. So, imagine that you have some function, and there's the leaf blowers. Love that. This is going to be very, very loud for a period of time. It'll be like 10 minutes or so. So imagine that you have some function, right? Now you can do a sinusoidal or a Fourier decomposition of that function. So it's just a whole bunch of different waves with different frequencies and different amplitudes added together to give you a function. So virtual particles are like those different sine waves that add together to give you some more complicated function. But if I were to tell you that that the electromagnetic field was arranged in a certain configuration, and then you were to tell me, but actually it's arranged as a bunch of different sine waves, and those sine waves are real, you'd be mistaken, right? And so that's what virtual particles are like. Virtual particles are like part of a Fourier decomposition, or more precisely, kind of like a Taylor series approximation of how to describe a more complicated field configuration. The field configuration is the physical thing. We just express it mathematically as a sum of different things that we call virtual particles. Hopefully that helps. I gotta hydrate a little bit. How theoretical is current physics? Is it less reliable than physical experiments like dropping an apple to observe gravity? I don't know what you mean by reliable. Current physics very much uses real experiments. They're called experimental physicists for a reason. So they do physics. How many papers have you published? If by published you mean in academic journals, like something like a dozen. If you mean like uploaded or like, you know, are in the publication process, probably closer to like 18 or 19. I'd have to count. But you can go read them on my website, which you should check out. My website is here. It's just blitz.phd. There's no .com. It's just .phd. See? Check it out. Here's there's an about me page. Hey, look, that's me. There's a research page. There's like a science communication page. You can check out my CV if you want. There's not merch yet. We're working on it eventually. Oh, but also on my page, because again, because I'm shilling for myself and trying to indicate that yes, this is how I make money, and TikTok is very unreliable, so I would really much like to have a reliable streaming system than having to rely on TikTok paying me enough money. There are links down here that you can click on my website. They're very much hidden, but they're there. Support me. There's a Patreon, a Cash App, an app called Buy Me a Coffee if you prefer that. All down here. I'm going to add Venmo. I do have a Venmo now there. I just haven't updated it yet, but it's there. So if you want to support me, there are ways to do so. From Adam with the $5, thanks to leaf blowers, I'll definitely never understand virtual particles. Just kidding, that's great, thanks. Yeah, I understand that. I understand that a lot. Make a Blackboard plushie. I don't know how you can make a Blackboard plushie. I don't know how that would work. If you had black hole merch, could you make it mass accurate? Probably not. I suspect Blitz doesn't want to retire from research. He does this to fund being able to do research. Yeah. So, I guess the question is why are you doing research, right? Well, look, the reality is that the reason why most theorists get paid at universities is because they're teaching, right? And because they're mentoring students, they're teaching. And the research is not the reason they get paid unless they have a grant, right? So in the same way, you can think of what I'm doing as funding my research in the same way that a professor at a university is funding their research by teaching. So yeah, I mean, like, I could probably not double my income, but I could probably substantially increase it by just live streaming all day. But I don't want to. I'd rather spend, 3 hours, 4 hours a day, or 3 hours a day doing live streaming so that I can fund the research that I'm interested in doing. From Nishil Savla, thank you for the 20 Indian rupees. That is appreciated. There's a good question that I wanted to ask, or that somebody asked that I wanted to answer, but I don't remember. I don't remember seeing it. Does there exist a third and fourth derivative for position? Yes. You have position, velocity, acceleration, jerk, snap, crackle, pop. How does Hawking radiation escape a black hole pole and not get sucked in? Because once it's past the event horizon, it's not hard to escape. You just have to be massless, and then you'll escape going the speed of light. If one could magically invent one piece of test equipment to answer a burning physics question, what would it be? A particle accelerator the size of the solar system? That'd be a good way to do it. From Lycon with the 500 yen, bumping a question from another kind chatter. Is there a chance space isn't what we think it is? I guess. It could be like discrete, it could be emergent. We currently think it's like a continuous four-dimensional spacetime, but it could be that those things are not fundamental, that they emerge from something else, but we currently have no evidence to support that. And from the Pellis with the $2, how does Wi-Fi work? This is probably a better question for like a signals engineer, but I'll do my best. So first you have to understand that we can communicate, we can send information via electromagnetic waves, like radio. Wi-Fi is basically radio. It's sending information to and from your computer, and then it's converting that into electrical information that it then sends along a cable, for example, or along some sort of a optical fiber. But wait, if virtual particles aren't real, I believe you. I just don't understand. How does the Casimir effect work mechanistically? The Casimir effect doesn't need virtual particles, and in fact, I've made a video about this. If you just use the virtual particle understanding of the Casimir effect, you actually find out that you don't get the right answer in the except in the small alpha limit, or the small fine structure constant limit. Rather, the Casimir effect is better explained as a relativistic van der Waals effect. So it's basically, you know how like two molecules can attract each other even if they're both electrically neutral? They don't form a bond, but they can attract each other, kind of like geckos' feet sticking to the ground or sticking to a wall. There's like a relativistic version of that happening for the Casimir effect, and you can perfectly well account for it that way without virtual particles. Please answer my question. I have to see it. I'd have to see it. I'm sorry. Are you still not using AI in research? I've never not been. AI has gotten sufficiently good. LLMs in particular. I don't know. Hard to say that they're actually AI. LLMs in particular have gotten sufficiently good that they're a good partner is not the right word, but they're a good sounding board for bad ideas. So if you have an idea and you want to know if it's bad, LLMs are really good at helping you figure out quickly that they are bad, so you can skip over them and try something else. They're also very good for reference finding. So yeah, I mean, I use it as part of my everyday workflow in the science side of the work that I do. I don't use them for like the videos that I make, except sometimes to find references to go like read. So for example, the lava lamp video that I made, I was basically like, I wanted to make a video about lava lamps. I'm so like, find me all of the physics papers that you can that are involved in lava lamps. And then it just gave me a list, and it's like, it was a very short list. So then I went and I read them, and you know, all that stuff. So that's the extent that I use it in like my video stuff. What are you doing research on? I generally, so I kind of have two branches of research that I work on. I do stuff basically on anything that interests me that has to do with gravity, and then also I do stuff in kind of pure mathematics on the geometry side of things. Can gravitational waves be reflected? Not as far as I know. They can be bent though, by like strong gravitational fields. From Garain with the $5, what do you think of the ER equals EPR conjecture? Entanglement is actually microwormholes. I'm not convinced of it, but I'm also not super well read on it. So it's hard to say. I don't want to have a particularly strong opinion on it. If virtual particles are fake, how do charged particles exchange momentum from the underlying quantum fields? What is the clock field in quantum mechanics? So the clock field is not something that exists. It's just like a proposed mechanism for how you can have quantum mechanics arise. Sorry, not quantum mechanics, time arise from a non-temporal state. And so it would just be some field that has a state that is arranged in such a way that it, like, there are distinct states, and those distinct states can kind of be thought of as clock ticks. LLMs are incredibly sycophantic, so prompt accordingly. They can be, yeah, of course it does depend on how you prompt. It also depends on which LLMs you're using, which models you're using, and things like that, right? Is it possible that space-time at very small distances, space is not Hausdorff? We'd be using a pseudometric, of course. For example, could space be better described as a scheme than a manifold? Bro, I don't know. I'd have to think about it more. I'd be very, very troubled if that were the case. Let's put it that way. Planet Earth is studied as what type of manifold? Well, the surface of the Earth is a two-sphere. Have you understood hard math concepts at their fundamentals, like abstract intuition? Yeah, depending on the math, yeah. Are you a millionaire yet? No. Why is quantum mechanics symmetry broken for the virtual particle Hawking radiation theory? I don't understand the question. Why quantum mechanics symmetry broken for the virtual particle Hawking radiation? The symmetry isn't broken. Were you surprised by our lack of understanding specific elements of the lava lamp? I was very surprised, actually. That's why and in fact, honestly, that's why the video went so viral. Or it didn't go so viral, but it has like 600,000 views or something. The video did so well because it's really surprising that we know so little, or that we don't have a complete story about what lava lamps are. What's a scattering amplitude? Does it dictate how spread out a particle wave cloud is? No. So scattering amplitudes are used in particle colliders. They're used in particle physics. And so a scattering amplitude is basically telling you something. It's telling you something about the probability of having two particles with certain properties come together, interact, and then come out with perhaps different properties or different particles. It basically tells you the transition probability from two particles coming in of a certain kind to two or more particles going out of a certain kind. That's what the scattering amplitude tells you. And so if you want to figure out what the probability is of two protons coming together, smashing, and then leaving in the form of, I don't know, a Higgs boson and, you know, two electron antineutrons, or two positrons and two electron antineutrinos or whatever. If you wanted to do that, that's a scattering amplitude. You're asking what's the probability that these inputs will lead to those outputs. Do you have a Telegram channel? No, I don't. Is the universe's expansion dark energy stretching space-time fabric? Not really, but it's not really a fabric, so it's just the universe is expanding. When you were talking about the clock field, I thought you were referencing a gravity field. No. Would you say that planet Earth is locally flat but globally spherical? Well, locally flat, so there's kind of two senses that you could have locally flat. There's locally flat in the sense that like literally all Riemannian manifolds are locally flat, insofar as, you know, you can always choose coordinates so that the Christoffel symbols are 0 at a point. And so locally it looks like Euclidean space. However, the other sense of locally flat, which is more relevant here, is just whether the Riemann curvature tensor is 0 at a point, or at, you know, at each point. And in that case, no, the Riemann curvature tensor of the surface of the Earth is not 0. So I wouldn't say it's locally flat. Is black hole evaporation proven? Probably not, no. But we've gotten very, very close. So there's this idea that you can kind of simulate black holes by using acoustics rather than gravity. And so then instead of having a speed of light limit, you have a speed of sound limit. You can form acoustic black holes, and you can even show acoustic black hole event or black hole evaporation, which is really cool. They're sometimes called dumb holes, by the way, which seems very inappropriate. Can quantum entanglement be used for instantaneous communication? No. There's something called the no communication theorem, which proves that you can't do that. Know of anyone doing classical scattering theory with gravitational interaction? Yes, actually I do. These are more mathematicians that do this than physicists, though. The results that I know of are by Chang, Ching, and Yang. And also Zworsky and well, the kind of the original paper that you should look into is by Graham and Zworsky. I can pull up for you. And this isn't the first paper, but this is the one that's most important, most relevant to my research. So they're doing specifically scattering in conformal geometry, where you have non-zero curvature. And this is like a super famous paper. So check it out, take a screenshot. But the answer is yes. How does space-time work since space and time are two different dimensions? Well, they're two different kinds of dimensions that are kind of together in one four-dimensional space-time. Where's the join button? I don't know. Can you give some broad tips on doing research and studying? Depends on what kind of research. So there's not really tips I can give you for research. Research is something that you learn how to do from a mentor. I don't think that there's good tips for it besides just reading a lot of papers. But for studying, no, I don't have any good tips. Sorry, I have to jump down to the bottom. I'm way behind. Way behind. Why can't you make perpetual energy of two magnets in an enclosed area? Where would the energy come from? Energy in a small local system is conserved, so you can't make energy forever because that energy has to come from somewhere. I heard that we physically can't touch anything. Is that true? No, not really. What do you think about joint work between physics and philosophy? It's interesting. I think it's worth doing. Is the amount of suffering in the natural world is beyond all decent contemplation? Maybe. Why could a spaceship never reach the speed of light if it has enough fuel? Because it can never have enough fuel. That's the point. Do you have an opinion on Leonard Susskind's theoretical minimum books? I haven't read them. I should, and I plan on expanding my library once I move, but not yet. I don't have enough room. My big tip for research is get comfortable sitting with hard problems. Yes, I agree. That's actually a good tip. Can you explain strange matter or the theories that potentially describe it? So strange matter is a kind of matter that exists. It's just matter that has quarks in it, or that has strange quarks in it. Kaons are a good example of such mesons that have quarks. Kaons are a good example of mesons that have strange quarks in them. But you're asking about this whole strange matter eating other matter. That's an idea. I think it was actually, I don't know if it was first proposed by Witten, but let me just double check the history here. I could have sworn that Witten was involved in this. Yeah, the strange matter hypothesis was proposed, I guess, separately by Arnold Bodmer in 1971 and then by Ed Witten in 1984. The idea is that there might be a more stable configuration of matter where you have one up quark, one down quark, and one strange quark, but we don't know if that's true. If that is true, then it could convert other matter to that form, but, it's hard to say. What research do you do in pure math? I'm a mathematician that studies algebraic topology and algebraic geometry. I do differential geometry. Specifically, I do conformal geometry. And I'm interested in studying like Einstein manifolds in Riemannian signatures. So that's that. That's the kind of stuff that I do in pure math. Do you have a physics of computation channel you could recommend? I don't. Oh. How's your health? I'm doing okay. I do have celiac disease now, which sucks, but I feel okay. I don't feel sick. So why are the fundamental laws of physics what they are? Do we have literally no idea? Perhaps this is not the kind of question that has an explanation. Can you make a video on the books you've read? I don't read a lot of books. I read a lot of papers. Can you fix your glasses so I can take the smart guy serious? I'd love to, but they don't. This is like the glasses are bent, and I don't want to bend them in case I break them, because I would need to get new glasses then, and I don't have established care for an optometrist, which I need to do. So, but I do plan on getting new glasses somewhat soon. If light is emitted from inside a black hole, can the photons fall back into it? If they don't escape, then they don't escape. Why are the oh, okay, I already answered that. Who are the modern day leaders in the field, i.e. those famous pictures of Einstein, Bohr, Schrödinger at conferences? Who are the modern versions of those people? What are they discussing? There probably isn't a modern version of those people. If there's no friction in space, what's stopping the spaceship from just accelerating forever? Nothing, but accelerating forever doesn't increase your speed forever. 1 unit of acceleration, or a certain amount of acceleration over 1 unit of time, changes your speed by a different amount depending on how fast you're already going. Oh, okay, the person who sent the super with no text. My question is, I finished my MSc and I worked in gravitational waves, MIS kinetic theory. I have preprint on archive. How can I land a PhD abroad? Oh, that's hard. I mean, you have to apply, right? If you already have a publication and you have a master's, that should help. But you'll need really good letters of recommendation, unfortunately. Do you think that we could be inside a black hole? I don't think it's very plausible. Why not medical physics? Do you not like making money? I don't find it interesting. I find it like supremely boring. I'm glad other people find it interesting and other people like doing it, but I don't. What's your opinion on nuclear energy as a primary source of energy production? If we can make a nuclear fusion reactor happen, then I think that that's definitely worthwhile doing. Why is nuclear energy so frowned upon? Because of Chernobyl? You already you answered the question in your question. What has an approximate mass of 1.27 GeV per c squared? Is that the strange quark? Yeah, I think that's the strange quark, right? Oh no, I got it wrong. Yeah, that has a massive. Is it the charm quark? I thought the charm quark was like 1.6. Oh no, it is the charm quark. Okay, the charm quark. Cool. Which theory of time do you consider most plausible, and which models do you believe best elucidates the events preceding the Big Bang? I don't have to answer your second question, I don't have an answer for that. I don't know if we have a model that best elucidates the events preceding the Big Bang, at least not yet. But I think that the B theory of time is more correct than the A theory of time, if that helps. What are your thoughts on the Perimeter Institute? It's a really good institute. Really, really good. What's your favorite planet? I like Earth. Is it true that energy is not conserved over large distances? Yes. What are the biggest issues with space audits Alan and Shane's conceptual flat Earth model? Well, that it doesn't make good predictions about the way the world is. It makes a lot of post-dictions, but it doesn't make good predictions. Why aren't there modern versions of Einstein, Schrödinger, etc.? Were they just exceptionally great, or do they just get low-hanging fruit? It'd be one thing to say it's low-hanging fruit. I don't think that I don't think that the Schrödinger equation were low-hanging fruit. What I think is the case is that they were the kind of fruit that a single person could reach, right? A brilliant person nonetheless, but still a single person. The thing is I just don't think that the kinds of results that we need now are the kinds of results that can be found by a single person. Like, we have enormous large collaborations nowadays. It just seems like the amount of knowledge that's required for one person to make such an enormous breakthrough, like Einstein, like Schrödinger, like Bohr, etc. did, is just too much knowledge for one person to have. Like, you would need too much knowledge, and you can't accumulate that much knowledge in one lifetime. So it takes a lot of small steps to make progress. At least that's how it sounds like. Also, the other thing is that for the paradigm shifts that are required, we would need physics breaking experimental data, and we don't have that. Our models are so accurate right now that we just, like, you know, there's not experimental data that we need to explain, really. I mean, there's a few open problems, but not like some big conflict with experiment. Between theory and experiment, I should say. How do photons know that they're observed? They don't. They just interact with things when they interact with things. Are you a determinist? Is the Everettian interpretation of quantum mechanics still your favorite interpretation? Yes and yes. Super chat guy, ask your prof for collaborators. 3/5 of my PhD admits were advisor networks. Yeah, that's true too. I got my postdoc because of advisor networking. So yes, unfortunately that is the case, that these kinds of positions are often given because of networking, not because of just the raw power of your application. Blitz, so clock field just exists from the beginning then? There wouldn't be a beginning if there's a clock field that explains what time is. How long before being approved is the theory presented as immaculate? There's not like some formal process of approval. What do you think about the second law of thermodynamics? In some sense it's unbreakable, in another sense it's like not even a law. It's like a tendency. Does the fact that the conservation of energy isn't universal contradict hard determinism? No, not at all. Hard determinism is just that given the initial state, you can figure out what the final state is at any moment of time in the future, but that doesn't require energy conservation. What's boring about medical physics? Making a lot of money? I just don't find the problems interesting. It's more like applied physics than actually doing physics in a lot of sense. I thought you liked many worlds. I do. That's what the Everettian interpretation is. How can we estimate the age of stars? We have something called the Hertzsprung Russell diagram. So it's this guy. So we have this diagram, the Hertzsprung Russell diagram, which allows us to like basically characterize stars. And depending on where you are in your main sequence or what kind of star you are, they will have different lifetimes. And so it's hard to estimate how old a star is, but it's pretty easy to estimate like kind of the minimum age that a star could be, or sorry, the maximum age that a star could be. For example, if you have a supergiants do not live very long. Or if you have like one of these blue giants up here, they only live for 10 million years. Those stars can't be older than 10 million years, right? Or so. Whereas if you have a tiny star like our sun, which is somewhere around here, those stars can live to up to 10 billion years. So like they could be that old. From Garain with the $5. Thank you so much, Garain. Could you explain young Earth creationists say Uranus's magnetic field is evidence for their view and also why it's wrong? I'm not familiar with the claim. I'd love to, but I'm not. Do they claim that like Uranus's magnetic field is like too strong? I don't think I've heard this. Okay, so it has a unique and highly chaotic magnetic field, is tilted nearly 60 degrees from the planet's rotation axis and offset from the center by 1/3 of the planetary radius, causing it to twist into a long corkscrew shape. The planet rolls sideways on its orbit. I don't see why this would be evidence for young Earth creationism. Oh, no, I am familiar with this. Okay, yeah, that's right. There was a young Earth creationist who predicted the strength of the magnetic field of Uranus. And then we measured it, and the prediction was right. So, like, in some sense, this is like some evidence of young Earth creationism, but he wasn't like on the nose, right? He got like the right order of magnitude-ish. And it's not clear like how his prediction has anything to do with young Earth creationism. So from Ripped Reptilian, I can't fit my whole question. Look at #science, please. Look, I can't let you evade the limits of super chats that way, but I will anyway. While Starlink is designed for Earth-focused telecommunications, does its architecture, mass-produced, interconnected, autonomously managed satellite constellation serve as a technological blueprint or proof of concept for a modular Dyson swarm? Beyond the obvious difference in scale and solar distance, what are the primary physical constraints in scaling this paradigm to stellar energy harvesting? The primary physical constraints are A, energy transportation, energy transmission, B, scale. But no more evading. No more evading. There's a reason why. I mean, I didn't set this, but there's a reason why super chats are able to be longer if you send $5 rather than $2. Could the average person get a bachelor's in physics? Hard to say. What is the case is that there was a study done, I don't know, a while ago, that like the average IQ of a physics bachelor's degree holder, or maybe it was a physics bachelor's degree student, was like 125. Now, that doesn't necessarily, so that is significantly higher than above average. Significantly higher than average, rather. And that doesn't mean that an average person, say with an average intelligence, whatever that means, couldn't do it. It might be a selection effect, that it's people with higher IQs are the kinds of people who apply for physics programs, and that it doesn't say anything about success rates. But, you know, take that piece of data as you will. Just a curious question. What do you think about chemistry predating physics as a quantum theory? Interesting. I mean, chemistry is a little bit easier to grasp and easier to do experiments with, so I'm not so surprised. Can you explain the Maillard reaction? That's a cooking thing, right? I cannot. I don't know anything about it. By the way, oh, it's 10:32. That means, okay, so just to make everybody ready, we are about to transition over into subscriber only, member only, super chat only, or super fan only question session. Anybody can watch. You guys can still stick around and still hear me talk and still hear me answer questions. But the only people who will be able to send questions over text will be people who are part of the $5 a month membership, whatever, on whatever platform you are. However, because that also reduces the amount of questions that we get, and that means A, I will answer literally every single text question that we get, and B, it means I will also be taking guests from over voice. So if you do have a burning question that you would like to ask, you can either join via Discord or you can join via voice. On TikTok, either one's fine, and I will take your question eventually, but I'm going to be answering text questions first. So I'm going to transition over to that really quick. It'll just take 2 seconds. This is an incentive. Usually I used to only do these live streams for an hour and a half because I can only talk for an hour and a half rapid fire really in any one sitting. But because the questions come more slowly when I'm doing super fan questions, because the questions come more slowly when I'm talking to people, I can actually sustain it longer. So this is in addition, it's not a replacement, so don't feel too bad. So I'm just going to transition that really quick. Otherwise I would just end the live stream here if I wasn't going to do this. So hopefully you don't feel too bad. And if you really want to ask your question, you could still send a super chat as a one-off, or consider becoming a $5 a month member. Not so much. I mean, I understand that not everybody has that, and so that I totally get. But, you know, if you can, it helps me a lot. In fact, we actually just got one from lol what? Thank you for joining. I appreciate you. All right, so I'm going to start taking questions from the chat. We have chat from a whole bunch of different places. We also have a bunch of guests in the guest box, so we can start taking them too. Why can't the Schrodinger equation be solved exactly for any atom bigger than hydrogen? Because it's nonlinear. It's a nonlinear partial differential equation, which is just, it's not the kind of thing that analytic solutions exist. Now, we can solve them numerically, just not analytically. Okay, let me just double check something really quick. Sorry. All right, let's bring up our first guest. Oops. Go live together isn't available while live access is suspended. What? What do you mean live access is suspended? Maybe they had live access suspended, but we do have some guests from Discord, so we can bring at least one up. We have a guest, Toonhound. Toonhound, how's it going? What questions you got for me?
I am good. I am the opposite of a physicist. I'm a cartoonist, so my brain is much smoother than yours.
I don't like smoothness, though, so go ahead.
Okay, here's what I can't wrap my head around. The universe is expanding, correct?
Yep.
Expanding into what? What is
It's
outside
not.
of it that
So
okay.
it's not expansion like the edges are getting farther away from each other. That's not what's happening. It's expanding like everything in the universe is getting farther away from everything else in the universe.
So the universe is okay. So if someone magically transported me to the edge of the known universe, what's beyond that?
So the edge of the observable universe, there
Yes.
is such an edge, and there's almost certainly just more universe beyond it.
Okay. So when we say the observable universe, that's just how far we can see.
Yep.
Okay. All right. Well, I'll do my best to keep that in my head.
Good. Good.
All right. I appreciate you.
Of course. Take care.
Yeah.
I always do find it funny because a lot of people do this, by the way. A lot of people will say, well, they'll come in and they'll be like, I'm very much not a physicist. And like, okay, I get why you're saying that. But if you were a physicist, you wouldn't be here asking these questions. You would know the answer. You would know how to find them, right? So I always do find that funny because, like, obviously you're not a physicist. That's why you have these questions. From Cade Green with the $5. To your last point about our models are all, your last point about our models are already extremely precise. That is reminiscent of what Planck was told in late 1800s. How is now different? Well, the point is that in the late 1800s there was there was like all of this new experimental apparatus that was coming online. In the late 1800s we have the cathode ray tube, which is a beam of electrons. Like this is literally the first particle accelerator was invented in the late 1800s. We have conflict in thermodynamics. We have explanation, we have developing theory of the atom. So in the late 1800s, the tech that we had was finally becoming available so that we could do fundamental science with the tech, and B, we had a whole host of unanswered questions that, maybe they weren't important questions, but they were certainly unanswered. Like, what are atoms? We didn't know that in the year 1900. We didn't even know if atoms existed. What we did know is that matter comes in in discrete chunks. This is known from or matter comes in like discrete ratios rather. This was known from chemistry, and we know that molybdenum is somehow different from hydrogen. But like, why? Why is molybdenum different from hydrogen? That was like a completely open question that we had no idea. And then what was the deal with these cathode rays? What was the deal with classical mechanics making or classical physics making incorrect predictions about black body radiation? Like there were a lot of unanswered questions. And so like the point is that we don't have those unanswered questions. We have a few unanswered questions fundamentally about physics. Like we have questions about like what is dark energy, what is dark matter, how does gravity behave at the quantum scale? But the trouble is that while the questions that they had 125 years ago, 150 years ago, were the kinds of questions that they could build technology to, that they had the tech to study, the questions that we have access to, it's not clear if we'll ever be able to produce the technology to answer those questions, because they might just be the kinds of questions that are so far out of reach of like you need such big particle accelerators or so accurate telescopes that we just don't have the tech to build those. And from Sugar Free with the $5, what are your thoughts on claims made by the company Exodus Propulsion? I've never heard of it. I have no idea what that is, so I don't have any thoughts on it. Sorry. What happens to your potential energy to fall back to the planet when you go high and fast enough to escape orbit? Your potential energy decreases, or your potential energy goes back to zero. Technically, your potential energy increases because potential energy is negative. So when you're close to the Earth, you have more negative potential energy. As you get further away, your more negative potential energy gets closer to zero. And so because your potential energy is increasing, your kinetic energy decreases. My thing is, would affect the area with 1G gravity at the same size as the Earth. I've been arguing with AI to phrase this right now. I'm all confused. It's okay to be confused. Clearly there's that Truman Show set at the end of the universe, like in Hitchhiker's Guide. Yeah, exactly. That's exactly what it is. I'm either getting a sore throat from talking too much, or I'm getting a sore throat because I'm getting sick, and I really hope it's not the latter. Really hope it's not the latter. But I have a, I have a little tickle in my throat right here. But we don't have any questions. We don't have any guests. So if you have a question and you want to ask me it, what you can do is you can join the live stream right now on TikTok, or you can join the Discord server and ask me there by going to this URL that's behind me. In the meantime, though, I am happy to just yap. Sorry, actually, one sec. I'm gonna blow my nose really quick. Don't go anywhere. Don't you hate when you blow your nose and then blood comes out? Isn't that the worst? One more. All right, I think we're good. Sorry about that. What was Newton most mistaken about? It's a good question. Probably like alchemy, but more than that, he was mistaken about. Well, I mean, of course, like everything, like relativity. Like he didn't know anything about relativity. He didn't know anything. I mean, he used Galilean relativity, which we know is wrong now. But he didn't know anything about electromagnetism. So to say that he was wrong about it or mistaken about it feels disingenuous. Give us some fun facts about neutron stars. Their magnetic field is so intense, and I made a video about this a while ago, but it's just a neat fun fact. Their magnetic field is so intense that it has the energy equivalent of the mass of like several Earths. From Cade Green with the $2, just supporting what you're doing. Thank you for answers. Of course. I'm glad I could be here to do this. Are pulsars a form of black holes or neutron stars? I'm fascinated by them. Don't they have a magnetic field strong enough to destroy the Earth from light years away? So they're a form of neutron star. They're neutron stars with sizable magnetic fields that are spinning extremely fast. And so this causes the sizable magnetic field and the angular momentum basically causes them to shoot out jets in either direction. And so that's why we get like these kind of ticking clocks of them spinning. But no, they couldn't destroy the Earth from light years away. Their magnetic field isn't that strong. Light years is very, very far. The whole blowing your nose and blood comes out thing, it's not a sickness thing. It's just because the air is super dry. Is there any overlap between computational complexity classes with like P equals NP with physics? I'm intuiting a relationship there. No, I don't think so. Also, my nose is itching again. One sec. All right, now we're good. It was just one of those like itchy ones. We don't have. I'm really surprised. There's like several hundred people here that I imagine have questions, but nobody's actually in the guest box or on the Discord that's curious about, or that has a question that they want to ask me in person. And I promise I won't bite your head off. What's a Higgs boson? This is a good question. A Higgs boson is a fundamental particle of matter, or it's a fundamental field of matter. Let me rephrase. It's not even matter. It's a fundamental field, or it's a fundamental excitation of a field called the Higgs field. The Higgs boson doesn't really do much on its own. It can interact with other particles, but it doesn't really do much on its own. The important point is that the Higgs boson is evidence of the Higgs field, and the Higgs field is the underlying quantum field that is the source of mass for most particles of matter, like quarks, like electrons, etc. How long can I survive on a neutron star? Not long at all. Like, you die basically instantly. The gravity is too strong. What would the night sky look like if we were in an elliptic galaxy instead of a spiral? It wouldn't look that different unless the sky is dark enough that you can see the Milky Way. So if you can see the Milky Way, it just looks like a kind of like a streak across the sky. You wouldn't see that if we were in an elliptic galaxy. If you had to make a clock out of gravitational waves, what would be the best way to go about it? Theoretically, I don't know how you would, because the way that you make a clock out of photons is you like put two mirrors and then you just have the photon bounce up and down. I don't know how you're going to do that with gravitational waves. That'd be really tricky. Let's bring on a guest from TikTok, Draft Voice. Draft Voice, how's it going?
Hey, how's it going? How you doing?
I'm doing okay. What questions you got for me?
I heard this from somewhere, I don't know if it's true. Is it true that light is a particle and a wave?
Only a little bit. It's true that light is a wave, and those waves sometimes behave like particles.
How come? Is there like a reason for it?
Yeah, so you can think of a particle as like a packet of stuff or of energy, loosely speaking, that is localized in space and comes in chunks. And so what is true is that light waves do come in chunks, but they're not always localized in space. So they come in chunks called photons. Those photons can be spread out over space, or they can be localized. When they're localized, they behave like particles, because a particle is like some sort of chunk of energy that's localized in space. And so when they happen to have that particular configuration, they look like particles.
Oh, okay, that makes so much sense. Thanks for telling me that.
Yeah, of course. Anything else?
No, thank you, bro. Appreciate it.
Okay, take care. We have some more questions. Do you think galaxies with quasars, this is from Garain with the $5, do you think galaxies with quasars are sterile? If our supermassive black hole were an active quasar, would the radiation kill us from this distance? I made a video about this a while ago, answering this exact question. Probably not. If you were 30,000 light years away from a quasar, even a quasar like a quasar that would have powered the supermassive, or even a quasar that would have been powered by the black hole at the center of Andromeda, which is much bigger than the black hole at the center of the Milky Way, it would look like a bright star in the sky. But if I remember correctly, because I did a rough back of the envelope calculation here, if I remember correctly, the actual amount of dangerous X-ray and gamma ray radiation wouldn't be enough to like sterilize a planet from 30,000 light years away, if I remember correctly. So, but it would be a substantial source of gamma rays, just not enough to like sterilize a planet, just enough to, cause, you'd probably want to wear sunblock or something. Do you know of any sci-fi stories that use wick rotations for a time machine? No, I don't, but it's a fun idea. You should write it. Wouldn't a starship with artificial gravity basically be a cosmic hazard, accidentally dragging a parade of asteroids behind it to every planet it visits? Only if by artificial gravity you just mean it's just heavy enough that it has its own gravitational pull. But not necessarily. Like, just because you have strong gravity doesn't mean that things are going to orbit you, which is what would be required in order for you to drag them along. And from Pone Donkeys, if you could rewrite any of the laws of physics, which one would you change? What would you change about it and why? I like the laws of physics. They are the kinds of laws of physics that allow me to exist, so I probably wouldn't change any. What I might do though is I might somehow make it so that quantum gravity is more easy to study. I'll probably get too fangirly and faint if I join the call. Okay, fair enough. Is it possible to create a photon with a wavelength larger than the diameter of the observable universe? I guess in principle, but then we wouldn't know it's a photon as opposed to just a non-zero electromagnetic field. And from Sparrow the Sissy, geometry question: why are there only a handful of platonic solids to make fair dice? Why couldn't we make a 25-sided die, for example? A good question. Why are there only a handful of platonic solids? I don't know. I haven't thought about that. Maybe I'll make a video about that. Sounds like a cool topic. And then we'll bring up another guest soon. Because the interesting thing is, in 2 dimensions, we have an infinite number of platonic solids, right? An infinite number of 2-dimensional shapes that have equal length sides. But in 3 dimensions, we only have like, what, 6? Where all the faces are the same size? So like, that's kind of interesting. I'm sure the answer is actually fairly simple, like, and I'm sure it's a topology statement, but I can't articulate why that would be the case off the top of my head. All right, let us bring up Lint from the Discord. Lint, the Snark Maker, how's it going?
Hey, how you doing, Blitz?
I'm doing all right. What questions you got for me?
Hey, I want to follow up on a question that you answered for me yesterday about the quarks in one nucleon affecting the quarks in another.
Mhm.
Would that cause, like with the electric force, if a say a quark with a blue charge, would that induce a change of a blue quark in another nucleon to change its color charge?
It's a little bit more complicated than that. So what's happening when you have so what we're really talking about is like, can the strong nuclear force cause protons to be attracted to other protons, or protons to be attracted to neutrons, or whatever? That's really what we're talking about here.
Okay.
And so really, if you want to think about like what's actually being exchanged here, gluons are not the source of the thing being exchanged. What's really being exchanged are pions, virtual pions. So you kind of want to back out. Like once you have the hadrons, really the fundamental fields can really be integrated out. They're not really relevant anymore, and instead you should talk about something called a pion field. And the pion fields are now kind of controlling the relevant interactions between hadrons, and these are all color neutral.
Oh, okay. I see where I think I see where you're going there. All right. So no, not really, because those interactions don't carry a charge, that a color charge. Okay.
Yeah.
Okay, cool. I think I get that. So this one might be silly, but with the proton and neutron, with them being three quarks, but we know that they are, at least from all the representations I've seen of the transfer of the gluons, these are always bouncing around their color charge, and
Yep.
These are nowhere near static.
Right.
But because there's three quarks, at any particular instant, are they like always planar?
Well, they're not point particles,
Does that
right?
does that question make any sense?
Probably not, because they're not point particles, right? They're you could think of them as like smeared out blobs. So
Okay.
and also those aren't the only quarks that are present. Those are the valence quarks. They're kind of the quarks that make up the if you consider the mass of the kind of the mass that the thing would have if everything was at rest, these are the things that contribute mostly to the mass, that would contribute mostly. Of course, the actual mass of a proton is mostly due to its kinetic and potential energy of the stuff inside, but that's neither here nor there. The valence quarks aren't the only quarks that appear, though. You have components of your proton or neutron that contain a whole bunch of other quarks that are kind of like fluctuating around in the in the vicinity of these three quarks. So it's not even the case that those are the only quarks that are ever present.
Okay. All right. Now that you say this reminds you of a thing that I think I saw, that because of the energy probabilities, you can get like one of the heavier quarks.
Yep.
For just
you can find charm quarks inside of protons.
Right. Okay. Cool. All right.
Which is surprising because charm quarks have more mass than a proton.
Yeah. So another very naive quark question is, with that we are generally only seeing the first generation quarks, and we know that there's the charmed and the charmed and strange and the top and bottom.
Mm-hmm.
And their masses are going to be related to their energies, if that is even not exactly the same thing. Do these things only show up because they present as quantized at those energy levels, and that's why there's no...
Do the quarks only show up because... What's the question?
I'm sorry, I'm probably forming this question poorly.
You're fine.
Is if the heavier quarks have different energy levels, but do they only kind of coalesce into a, and I know that you said they're not point particles, but do they really only become those heavier quarks at those energy levels? And is that like a quantized thing for quarks?
Well, look, so what a particle
This is
is
probably
it's
malformed. I'm really sorry.
no, I can clarify. So what a particle is it is a minimum what a massive particle is anyway. A massive particle is a minimum energy excitation of a quantum field. And so
Okay.
if quantum fields can have various quantum fields can have, you can put energy into a quantum field via some sort of interaction. And if you put enough energy in, then it can form one or more particles, where those particles have, each particle has this X amount of energy plus perhaps whatever its kinetic energy it has and whatever potential energy it has. And so the point is that you have your charm quark field, you have your strange quark field, you have your top quark field, bottom quark field. These are all fields that they always exist, but until you dump enough energy in them, they won't pop out a particle.
Okay.
And so, in order to put that energy in them, you need to interact with those fields, and those fields can be interacted with in various ways by producing W bosons, for example. W bosons interact with all of the quarks, all of the left-handed quarks anyway. And so, for example, the W boson can then give its energy to one of these fields, depending on, statistics, basically. And it can, and by doing so, it can excite these fields and produce quarks, because it gives its energy, and that energy is captured by these fundamental excitations. So in a sense, yes, if I'm understanding your question properly, but that's true about the up and down quarks as well. And it's true about the electrons, and it's true about, it's less true about gluons, because gluons don't have a mass. It's not true about photons, because photons don't have a mass either. You can create arbitrarily low energy photons if you want to. But this is all to say, yes, this is generally how what particles are. They're excitations of the underlying field, and sometimes those excitations require a minimum amount of energy.
Okay, you absolutely clarified the idea that was in my head. That's great.
Good.
Could I ask a gravity black hole question?
Sure.
With around rotating black holes, we have frame dragging.
Yep.
That's a distortion of space-time.
Yeah.
Is that an equivalent type of distortion that is like curvature? Or is
it's a kind of curvature, it's captured by curvature, the curvature in space-time.
All right. Okay, good. I wanted to make sure that I had that intuition in my head correct, thinking that these are effectively, the same type of behavior of space-time curvature.
Yeah. So
right, cool.
one way to think about this is that around a non-rotating black hole, or around really anything with mass that's not rotating, you can kind of think of the future time-like direction kind of being bent in the radially inward direction. That's the kind of curvature that you want to think of. Whereas if your thing is rotating, now it's not just bent in the radially inward direction, it's bent in the radially inward and also kind of around direction. That's all.
And does that also bring along angular momentum and conservation thereof?
Yep. Yeah, you can talk about there's a sensible way in which you can talk about the angular momentum of a rotating black hole, for example. And of course, if you the total angular momentum of a black hole after you've dropped things in, with the black hole has some initial angular momentum, you drop something in with some angular momentum, the total angular momentum will be the sum total of whatever the initial and final angular momentum, or whatever the initial angular momentum were.
Do we have time for one more?
Sure.
Okay. A black hole, it has a mass, and its mass is related to the size of the event horizon.
Mm-hmm.
If I remember from one of the other videos.
Yep.
Is this a strictly linear relationship?
Yes.
Okay. So when black holes go through their evaporation phase, in the distant future, does that also mean that when a large black hole begins to shrink, all of these are on the same shrinking curve. They're
Yep.
at some. Oh, okay, good. All right, that's all right. I was hoping that I had thought.
Well,
that
okay,
out
let me
correctly.
clarify. That's true for non-rotating black holes. For rotating black holes, like,
Yeah.
you know, there's something called the no-hair theorem,
Uh-huh.
which is just this idea that like a black hole has at most 3 characteristics. It has its mass, its charge, and its angular momentum. And so if you have two, let's throw away the charge thing for a minute. If you have two black holes with the same mass and the same angular momentum, then they will decay and they will evaporate in the exact same way. But like the rate of decay, of course, is going to depend on things like the angular momentum. And so, if you have a massless black hole, or if you have a rotationless black hole, a non-rotating black hole with the same mass as a rotating black hole, they will follow different curves.
Okay. All right. Good. All right. So no, that's great. I did not realize that the rotating piece was going to cause a difference there. And of course, this implies that a black hole that starts out with a larger angular momentum is going to be different as it decays, even when it reaches the same mass
Yeah.
as another black hole that's got a different angular momentum.
Yeah, that's exactly it. And in fact, intuitively at least, you should think that the higher the angular momentum, kind of the faster it'll decay. And the reason this happens is because if you have a larger angular momentum, your in some sense your event horizon kind of shrinks because it's it's easier to escape.
Okay. That's all the things that I've been holding on to for a while. So thank you very much.
Okay, thanks for being here, Lynn. Take care.
You too. Bye-bye.
Let's answer some questions from chat if there are any, and then we'll bring up another guest. From Matt Swenson with the $5, how do you put energy in if energy isn't really a thing because it's only a number? Yeah, so what we're talking about is we're talking about an interaction. And so that interaction, you can quantify the energy of each field before and after, and that energy conservation is a good way to understand what's happening. It's not like physically a thing, but what you can say is that like the interaction causes an excitation, and you need a certain kind of interaction to cause an excitation that can produce a particle. And so we can quantify, or we can describe what kind of excitation it is by talking about the momentum transfer or the energy transfer involved in that excitation. Even if this is just a number, you can say that the initial state A in field 1 has this much energy, and then after an interaction, the final state in field 1 has this much energy, and therefore the thing that it interacted with must have that much energy. And if it has that much energy, then that's enough for a particle to exist. That's the kind of interaction that allows a particle to exist. So like that's all I'm saying. And from Ruth Connor with the £2, I appreciate all your content so much. Well, I appreciate you, Ruth Connor. Thank you so much. Now let me make sure that I didn't miss any questions. If other universes exist, could they have different laws of physics, and could they collide with our universe? Well, I mean, maybe. This is like science fiction stuff. If we're talking about any sort of like multiverse that like physicists are talking about, usually they can't really collide with each other. These are not the kinds of things that can collide. But they are the kinds of things that could have different laws of physics. Sometimes, depending on which version of the multiverse you're talking about. Do neutron stars rotate? Yes, they do. Very much so. And from Sparrow, what would it take to harvest the energy from a planet's orbit? And which planet should we sacrifice for this? From a planet's orbit? I guess I guess the kind of the basic thing would be to put like a water wheel in its way. But like I don't think that you could actually do that, right? You basically need to make it lose energy somehow. So you need to slow it down. But I don't think that you could do that without having like some enormous infrastructure that spans the entire solar system already, which would probably take more energy than the one-shot usage of the planet's orbital motion. Yeah, so I think that the answer is probably it can't work. Let's bring up Goober47. Goober47, how's it going?
Hello.
Hey, what questions you got for me?
Yeah, I'm a physics undergrad,
Cool.
So my questions are not specifically about like physics. It's more about like career aspect of this.
Sure.
I don't know if that's okay to ask about.
That's fine. Go ahead.
Yeah. So I guess like, because I've been studying physics, I've been like debating heavily whether I should like pursue a career in physics,
Mm-hmm.
like get PhD or stuff like that, or if I should just pursue like engineering. And so like, I don't know if you have like any advice for like when I should pursue a PhD or not, you know?
Yeah. So nobody gets a PhD in physics because they want to make a lot of money.
Right.
That's just the reality of it, right? You will make a lot more money if you instead get a master's in engineering. That's just the reality of it. The question is just, what do you want to do? I mean, look, so the job market for doing physics, like getting a PhD and then doing physics as your profession, has been, it is currently very bad, but it's been very bad for like 20 years. So, you know, maybe it's a little bit worse now than it has been in the past, but really, how much worse is it? It's always going to be hard to find a job doing physics research. Now, you can get a job doing, you can get a PhD in physics and then go do something else, as long as your skills are transferable. So, for example, if you do a PhD in physics and you do like computational astrophysics or something, well, part of doing computational astrophysics is knowing how to handle big data sets, is knowing how to run simulations. And these are transferable skills. These are the kinds of things that people would be interested in. Maybe they're not the most applicable skills, but like specifically, but they are very transferable skills. So maybe it's possible there. But if your goal is to just have the best shot of making a lot of money, you'd probably want to go into like engineering of some kind.
Right.
That's
right. Okay.
that's just the
That makes
reality.
sense. Yeah. Because something like I've been wanting to pursue is stuff like with like photovoltaics, like
Mhm.
solar cells and stuff of that sort. So then I guess like the other question
That's a
is kind of
separate
if,
thing. So
yeah,
okay,
I would-
so
yeah.
if the physics you're interested in is the kind of physics that's like semiconductor physics, that's like the one branch of physics where which photovoltaics are. That's the one branch of physics where you can get so many jobs in industry, because
Mhm.
and you know, I'm sure the job market's probably better. You won't be doing pure research, but you will still be doing physics at the industrial scale to like optimize semiconductor manufacturing processes, or do efficiency or develop new semiconductors or whatever it might be. That is something that does have a lot of industry support, because obviously it's very, very profitable. So what you might want to do is, if that's what you're interested in, you could absolutely go do a master's in semiconductor physics, even apply for a PhD program in like semiconductor physics, which is, it'll probably be condensed matter or something like this. And you can always choose to master out if you'd rather do that. So you do your physics undergrad, you apply for physics PhD programs. If you get in, great. You do your master's program. Like the way that it works in the States is that you apply for a PhD program, and then along the way you just get given a master's. And then you can choose to leave if you want to, if you're kind of sick of doing what you're doing, or if you want to go work in industry and make more money, you can do that. Or you could stick around and keep doing your PhD program. If you get a PhD in that kind of field, like really focusing on like industry specific applications for like photovoltaics, I don't think you'll have a hard time making decent money and finding a job.
Okay. So you would say if I want to do photovoltaics, I should do what was it? You said
Like semiconductor physics is
right,
what it boils down to.
semiconductor physics, right?
Which would be like a branch of condensed matter.
Right. I was debating if I should do like material science.
There's going to be a lot of overlap there.
Okay. So like both of those two would be great programs to pursue, right?
I mean, like you could go into I don't know what branch of engineering would do this. I guess it would be closer to a material science, but if you do like condensed matter physics, especially if you do like more of the kind of experimental side rather than just the pure theory side, if you do that and you like are focused specifically on like semiconductor stuff, there will be so much overlap with material science that you may as well have done a material science degree as well. And so like that's the kind of thing that would be very I don't want to say that there's any guarantees, because obviously there's never any guarantees, but that's the kind of physics that industries actually want to hire people who know about, right? So you have a better shot of not to say that you would have a worse shot if you instead focused on some sort of material, if you got a material science degree, or if you went into an engineering field kind of focusing on this stuff, you might have an equally good or perhaps even better shot if you specifically did that. But if you still want to do physics, this is probably one of the best areas of physics that you can go into and have good job prospects.
Awesome. Yeah, that's kind of why I want to study it. I mean, I also am just passionate about the science of it, but
yeah, sure. Yeah. I mean, this is now I don't have any experience in those industries, so like my knowledge is basically based off of what people told me while I was in grad school, so it could be out of date. So what I would suggest you do is you could reach out to professors. They don't even have to be at your university, but reach out to professors who are like working in this area at universities and ask them what the job prospects are. Like they will have graduated grad students who most of them will have gone into industry, and ask them like, what are the odds of that like semiconductor physicists end up getting jobs in industry? And you could just like that's a question that they'd be happy to answer, and it's probably worthwhile to do.
Yeah. I'll have to, because I'm joining a lab for research in that sort of area, so I'll have to talk to my PI a bunch about it. But
yep, it's a good idea.
Yeah, thank you so much.
Yeah, of course. Good luck. All right, we do have some more questions. Give me one sec. So we have from Binary Ghost at the $5. Of course energy really exists. What the hell else have my crystals been aligning my chakras with? Pff, mainstream science, more like lame. Is true. Very true. From Garain with the $5. Tidal generators are indirectly taking the kinetic energy of the Earth-Moon system. That's true, but you would have to... the thing is in order for this to work, you would need to put like tidal generators on the sun, I guess, to harvest the tidal energy of the orbiting planets. I have a question. William Lane Craig often brings up Hilbert's Hotel as an objection to a path to infinite, but the hotel could never be full if you had an infinite amount of rooms, right? It could be full, you would just always have more room. And that's just not a contradiction. It's not an objection. It's just counterintuitive. But like, yeah, you can always find another spot to put. You can always find another spot to put people if the number of rooms in your hotel are infinite, even if you have an infinite number of guests, right? That's just the case. Counterintuitive, but it's just the case. Is the geometry of null hypersurface sufficient to reconstruct horizon thermodynamics without assuming semi-classical gravity? Probably not. Well, okay, actually, horizon thermodynamics doesn't actually, it can be derived almost classically, as long as you assume like the strong energy condition, or maybe not the strong energy condition, one of these energy conditions, you can derive this classically. It doesn't require semi-classical gravity. So yes, in principle, you can do this, but perhaps the geometry of null hypersurfaces isn't enough. We kind of just wrote that in the introduction as a way of like, basically just as a way of saying, yeah, this is like this might be a good application for this. But we didn't resolve the question, certainly. Somebody's been looking at my papers though. Does Carolean geometry represent a physical limit of space-time or only a mathematical curiosity? That's a good question that I don't know the answer to. So some physicists are very, very interested in Carolean geometry because they want to do something called it's like a kind of asymptotically flat holography. And so there might be some interpretation as to what the actual, like, that Carolean geometry might actually have some relevant physical interpretation. I'm not convinced. I haven't done a whole lot of stuff in Carolean geometry since because I'm not super convinced. For the orbit harvester, I'm thinking a big space facility that somehow captures energy from the planet swooping by and pulling something for a bit. Yeah, that could work, but it would just pull your big space facility along, right? From Binary Ghost with the $5, not sure if you would know, but are there any forms of electrical energy generation that is not solar, that does not involve spinning a turbine? You mean that does not involve boiling water? Well, okay, yeah, so the thing is the way that you convert motion So the reason why we spin a turbine is because it's rotational motion. So you don't need like an infinitely long generator to like convert translational motion into electricity. You have to spin something, otherwise your device has to get really, really big. So like if your goal is to convert kinetic energy into electrical energy, you have to spin something. You have to, basically the way that we know how to do this is you take motion of a magnet and you move it around around a conductor or near a conductor, and that generates electric fields, and those electric fields are what we call electricity. So like that's how you convert that's how we know how to convert motion into electricity. So, and the easiest way to do that, of course, is going to be using a spinning thing rather than a linear thing, because a spinning thing can be smaller than a linear thing. However, there is one method that doesn't convert kinetic energy into electrical energy. That's not solar panels, and this is called the Peltier effect, or whatever the inverse of the Peltier effect is. There's a name for it. It starts with an S. Oh no, the Peltier effect is the one that I was thinking of. The Seebeck effect was what I was also thinking of. No, I'm sorry. The Peltier effect is the one where you take energy and it produces a temperature difference. The Seebeck effect is the one where you get an electric potential. You generate electricity from a potential or from a temperature difference. And so the idea is that if you have a really hot thing and you put it in a you put it on one side of a thermoelectric junction, and then you take a really cold thing and you put it on the other side, there will just be an electrical current that's induced that flows between the two, or that flows between, say, the two wires of the thermoelectric junction. And this doesn't require spinning something. It's also extraordinarily inefficient. So yeah, there you go. Are we currently orbiting a black hole like our solar system? No, we're orbiting the center of mass of the Milky Way. The center of mass of the Milky Way is not necessarily exactly where a black hole is, and we're not, whether or not the black hole is there, we would still be orbiting the center of mass of the Milky Way. It's always just steam in a turbine. Not always. Just most of the time. Why is there more matter than antimatter? This is a very, very hard question that we don't know how to solve. If Manchak's theorem shows we can't determine global spacetime structure from local observations, what does that imply for cosmology? It might imply that we are fundamentally limited, but Manchak's result has been called into question if you only allow for physically plausible spacetime structures, i.e. those kinds of spacetime structures that can form via natural processes, not just kind of like by hand implementation of like random singularities or random discontinuities. If that's the case, then it's at least argued that Manchak's theorem probably fails to represent a physical reality. From Kurt with the $5, Dr. Blitz, can you go over the concept of the universe being infinite in time and space while also expanding? I'm still struggling. Cognitive issues. Yeah, so look, the expansion has nothing to do with edges. The expansion of the universe has nothing to do with edges. It's not like the edges are getting bigger or getting further away from each other. It's that stuff in the universe is getting further away from the other stuff in the universe. And that's happening between every sufficiently distant pair of objects. And so the only way to account for this is that in some sense there's more space between those objects if you wait 10 billion years than there was before 10 billion years had elapsed. So that's what we mean by expansion. Now, the universe could be infinitely large, meaning that you could go in one direction forever and never reach an edge or never loop back on yourself, and that could still be the case, that like there's more space between two things than there was 10 billion years ago. Neither here nor there. Now, if the universe is infinite in time, that would just require that either the expansion rate it's been expanding forever, but the expansion rate kind of like decreases asymptotically as you go into the past, so like it gets arbitrarily slow, so that you can get to like, you know, essentially the so that you don't end up with an infinite scale factor, or you just don't have expansion that happens forever. That's all. But that's a possibility. That you know, you have collapse, you have expansion, you have collapse, you have expansion, or maybe that you have like a period of like kind of stability, and then you have expansion and you have another period of stability or something like that. Now I should say that there are some situations where you can have expansion forever as long as the universe is sufficiently empty. If the universe is empty, then you can have expansion forever at actually like a fixed rate, and there's no issue there. Just called de Sitter spacetime. yeah, that's a little bit more confusing. The method of generating electricity through the tidal buoy system considered hydroelectric or something else? I don't think it's considered hydroelectric. No, there's a name for it, and I don't remember what it is. It's like tidal electric generation. Wait, isn't there a black hole in the middle of the Milky Way? There is, not exactly at the middle, but close to the middle. But that's not the thing that we're orbiting. We're orbiting the center of mass. If the black hole wasn't there, we would still be orbiting the center of mass. I'm really interested in pure math intersecting with physics. What kind of legit theorems in math usually end up being used in physics? I know there's Noether's theorem, but is there a general form? A general form of Noether's theorem, or a general form of like the kinds of theorems that are used in math? Because there's not a general form of the kinds of theorems that are used in math, but the general form of Noether's theorem is quite broad, and but it just happens to have nice consequences for physics. The kinds of legit theorems that are used, there are a lot of, so the kinds of theorems that I used are the kinds of theorems that show up in like differential geometry. So like characterizations of, dimensionality are kinds of things that would show up in physics. Results about like, Penrose's singularity theorems are legit theorems that imply the existence of black holes, for example. So yeah, I mean, there are legit theorems that are used in physics. There's not like a general kind of theorem, though, that's used in physics. There's just whatever one is relevant. Which energy condition do you think is most physically meaningful and why? It's not clear that any of them are. Is the black hole orbiting at the center of mass too? Yep. What's keeping the galaxy together? All of the mass that's attracting all of the other mass. The black hole, like the mass of the Milky Way's black hole is like less than 1% of the total mass of the galaxy. All right, let me drink some water. What does it take to bridge that gap between a mathematical theorem and the physical reality? You just need that the physical reality is described by the kinds of things that the mathematical theorem is talking about. That's all. So like, if you're talking about a Lorentzian spacetime, then if your theorem's about Lorentzian space or about Lorentzian manifolds, well, it seems like our universe is described by a Lorentzian manifold. That's what spacetime is. So theorems about Lorentzian manifolds could very well have physical applications. All right, let's bring up a guest from Discord. Let's bring up Drew. Drew, how's it going? You have to unmute yourself, by the way.
Oh, hello. My apologies.
You're good. What's up? What questions you got for me?
Yeah. So I have a question, if it's okay, about, I've heard you talk about how relativity like implies B theory of time from your perspective.
Yeah, at least it's strong evidence for it.
Yeah. So like I have like a bachelor's in physics, and I was just interested in like what that seems sort of like intuitively reasonable to me, but like, could you say, I don't have like that much of an education in philosophy, and I don't know, but like, could you say that like the future, like since there's still like a future light cone and like a past light cone, could you still say that like the future and the past don't exist, or like are you not convinced by that, I guess?
The issue is that there is a sense in which, okay, so you're familiar with relativity of simultaneity, yeah? I imagine that you have bachelor's in physics. Yeah, so you're familiar with that. So the issue is that how could it be the case? So imagine that there is a person, that there are two people, right? One's moving relative to the other so that their light cones, or so that their planes of simultaneity are tilted with respect to one another. Now, one person, and then say that there's a flash of light, such that, or say that there is an arrangement of two light bulbs that are spatially separated, such that, and they're timed so that from the, say, quickly moving person's perspective, just imagine that one person's on Earth and the other person's moving quite quickly relative to the Earth. From the quickly moving person's perspective, those two light bulbs flash simultaneously. Now, if you wait long enough, those light bulbs, the flashes from the light bulbs are going to get to the person that's moving, and they're also going to get to the person on Earth. And from the person that's moving, from the perspective of the person that's moving, they happen at the same time because the signals arrive at them at the same time, so they can infer that they did actually flash at the same time, right, if the signals arrive to them at the same time. But from the person on Earth, what they will find is that one of the signals arrives before the other signal, meaning that one of them happened, say, in the past relative to the other. So how could both of them be correct is the point. Regardless of the light cones, how could both of them be correct? How could these two things be at the same time but also at different times, unless one person's now is a different person's future?
Right. So like, would you say that like the reason why you like have this this argument is essentially that like you can construct any sort of like reference frame. You can construct some reference frame that contains both like something that's simultaneous to my reference frame, but also can contain like any arbitrary point in my future or past light cones. Is that like
an arbitrary point in someone else's future or past light cones?
Right, yeah. Like, well,
actually,
saying,
no, I'm sorry. It's literally outside their light cones. That's the point.
Right. But like so you have like the plane of like what's now, quote unquote, right?
Yeah.
And you can like have some other reference frame that like both contains like in its quote unquote now, which is different, of course, like both some arbitrary point that's now for me and some arbitrary point that's not now for me, right? And so like, is the argument just that like therefore, like I get that like there's no like mathematically preferred like now, but could you say that like would that really commit you to the idea that like all of time sort of like exists in the same like sense ontologically, or could you say that like also the now doesn't really even like exist in the sense that
you could say that, but then you're obligated to hold the position that like now doesn't even exist, which is far stranger. Like that just means that like, you know, time doesn't exist. By the way, the other thing, like the relativity of simultaneity, I'm sorry, is like the classical argument that gets you there. But honestly, once you start doing general relativity, you are working with a four-dimensional manifold. And the four-dimensional manifold doesn't have a preferred, it doesn't have a, it's not the kind of thing that grows, because that would mean that somehow time is flowing. But you're working with a four-dimensional manifold that contains time. So like when you're looking at a four-dimensional manifold, it doesn't really make sense to say that time is happening to that four-dimensional manifold so that it can like grow into the future or something. It's just like the kind of the underlying mathematical structures just assume that you have like a proper four-dimensional manifold where, you know, where like, you know, these notions of past, present, and future, these are just kind of like subjective notions. There's just a four-dimensional thing that contains all of space-time.
Okay,
or that is all of space-time.
I did take one like class on black holes in my undergrad, but it was like, you know, very basic like general relativity stuff. But yeah, I like kind of like understand what you're talking about. Okay, thanks. I think that answers my question. Although I have like one more thing.
Go ahead.
Okay, so I'm sort of like thinking about doing like an education thing, like perhaps teaching like high school physics and whatever. And so I'm interested, like from the perspective of your content, like how do you tailor it so that like people who aren't in physics can like understand it? I guess like people who don't.
Okay, so I'm probably the wrong person to ask for this. I'll do my best, but I'm the wrong person to ask for this because
that's fair.
Because for what it's worth, people, there's a comment that I used to get a lot more frequently than I do now, but I still get this comment pretty frequently, which is, who is your audience? Because what you'll find if you watch my videos is you'll find some videos are like super understandable for like someone who just has like a middle school physics education, and then another video requires you to have like a master's, having taken like 3 courses in quantum mechanics at like the master's level. So like honestly, I don't know. I kind of just talk about things that I'm interested in talking about, and sometimes they're technical and sometimes they're not. It's not quite clear to me how it is. Like, I don't interact with children on the regular.
Yeah.
So I've like the youngest people I've ever had to teach were undergrads, 18-year-olds, 19-year-olds, that were engineering students. So these were students who have already had calculus, right? So like, you know, teaching physics at a high school level where, you know, there's no expectation of calculus, perhaps. I have no idea how you would do that.
Okay.
But that said, there is a lot of literature on the pedagogy of physics. This is like an active area of research. It's very well studied. And so if you do decide to go in that direction, like get a master's in like physics education or something, you will learn. You will learn how to teach.
Yeah, I am, and I am taking like I'm sort of like in the track right now. I'm thinking like maybe doing like I'm in California, so I'm thinking of doing like a teaching credential and like perhaps like a master's
Sure.
in physics at the same time.
Where are you in California, if you don't mind me asking? I'm just curious.
Long Beach right now.
Okay.
I did my undergrad at UCSD.
Oh, okay.
And then I'm taking like the credential classes at Long Beach, and then I might get like a master's in like computational physics or something at the same time.
Sure.
I don't know. Like I'm thinking I'm more interested in getting a master's in physics specifically than like in masters
Then
in
like
physics education, I guess.
yeah,
But,
sure.
like,
Okay, I get that.
yeah, because like you know, like I'm definitely like interested in like communicating or educating about physics, but like if I had to choose like education or physics, I'd probably choose physics, right?
Sure.
So like I guess that's my thought process. But yeah,
But
I mean, I don't know if I really...
teaching high school physics is the kind of thing that's like we need good teachers, especially teachers who actually know physics. I have a friend who, well, I don't want to say too much. But anyway, you will not have a hard time finding a job. Well, okay, I don't know if that's true, but you probably have better job prospects teaching high school physics than you would finding a faculty position at a university.
Yeah, I know, and to be honest, like that definitely does is factoring into my decision making. Like I would be.
But also, it's like a valuable career. Like, it's one of those things where like, you know, there is value, of course, in doing physics research, like, you know, pursuing and, you know, pushing forward our frontier of knowledge. But also, there's value in educating people so that they can do that. It's much more valuable, in my view, than like working as a quant on Wall Street. So.
Yeah. I completely like understand that, and like I agree for the most part. Yeah. But yeah. Anyways, yeah. Thanks. Nice to meet you. Nice to talk to you. And
yeah, good luck. Let me know how it goes. Take care.
Thank you. Yeah.
From Binary Ghost with the $5. Don't go talking about how massive the Milky Way's black hole is. That's just uncouth and impolite company. I'm sorry. The black hole's bottom, or the Milky Way's bottom, is quite girthy. No, not girthy. Quite voluptuous. And from Binary Ghost again with the $5. YouTube and other self-published content in general is done best, in my opinion, when people are just putting out what they like and not worrying about audience. Yeah. Maybe that's why I've been more successful than people who do this intentionally. I have no idea. Like I chalk up my success on TikTok and to a lesser extent Instagram and YouTube with luck. But it's possible that the reason why one of the contributing factors to my success was that I wasn't really doing this with any sort of intention of creating an audience. I was just producing videos about things that I thought were cool and wanted to tell people about. So maybe that genuine nature or something was one of the reasons why I had some modicum of success. Who knows? I think that probably most of it was luck. Right place, right time, right topic. We have some more questions, and we'll bring up another guest. I have a question that's kind of long. Is it possible to ask during voice chat on Discord? Yes, but you'll have to wait your turn, and it might not. I mean, who knows whether it'll happen today. Is the center of our solar system actually the exact middle of the sun, or is it also slightly orbiting the system's collective center of mass? Yes, it is slightly orbiting the system's collective center of mass. It's actually slightly outside of the sun, and this is Jupiter's fault. So the orbit of the sun is not, the center of the orbit of the sun is not within the sun. It's slightly outside of it, if I remember correctly. Which mathematical modification of GR best avoids singularities without breaking well-posedness? Well-posedness of GR. So classically, it's not quite clear. Like well-posedness of like because GR is already a nonlinear differential equation, and modifying GR with higher order terms makes it a lot harder to study. So I'm not actually sure. I know that there are some models like Einstein-Cartan theory. I don't know if well-posedness has been studied for Einstein-Cartan theory, but that does avoid singularities. I know that, I just don't know. Can you explain the Hubble tension a bit? Is it still a problem? Any new findings on this area? Which set of observations are closer to the right answer in your opinion? So look, the Hubble tension is basically this. You can measure the expansion rate of the universe by looking at supernovas and essentially how fast they're moving away from us by studying their spectra. Or you can measure and that will tell you how fast the universe is expanding. Or you can take a model, like lambda CDM, which is the standard model of cosmology, and then you can fit the standard model of cosmology, you can fit the parameters of the standard model of cosmology by making observations about things like the cosmic microwave background radiation. And then when you do that, now you have a mathematical model that makes a prediction, that also makes a prediction about the expansion rate of the universe. And when you do that, these two things disagree. that's a problem. Because on the one hand, we have this kind of noisy signal coming from these supernovas, but this is a direct observation. On the other hand, we have a very clean signal from the cosmic microwave background radiation, but that signal is providing input to a model, and that model may or may not be right. My personal position is that I think lambda CDM is probably not right. I think that the data is probably fine, and we're just inputting it into the wrong model. I think that we probably shouldn't be assuming that the cosmological constant is indeed constant. That's my issue. That's my guess. But it is still a problem. People are still working on this. Hard to say what the final solution will be. I shouldn't say final solution. From Nimb with the 5 Brazilian reals, can you talk about the idea that black holes contain universes inside them? Like our universe could be inside another black hole in another. This is not it's not like a serious idea that people think about a whole lot. This is like kind of a shower thought. And it's not like mathematically well posed. It's not even clear if this is the kind of thing that's even possible. So no, there's not a whole lot to talk about. No, as far as I know, nobody's worked out the details of what we would expect to see if our universe was inside of a black hole. That's the reality of it. That one is crazy to me. Another example is 2 people different distances away from 2 lightning strikes. One sees them strike at the same time, and one can see them strike at different times. Yep, that's a thing. I'm just looking for more questions before I bring on another guest. Does holographic dark energy require space-time to have a fundamentally informational ontology? I don't know. Ask the people who came up with the idea. I was just doing some differential equations for the authors. I didn't really care about what the origin was. Now I know where to put the center hub of our orbital harvesting infrastructure. There you go. What metaphysical assumption do science deniers most consistently misunderstand? That scientific ideas can be tested. They think that it's just like all theories. Like, no, you can go out and you can test this stuff in the real world. All right, let's bring on another guest, Red Guardian. Red Guardian, how's it going?
Blitz.
Howdy.
I'm doing well.
Good to hear it. Glad to hear it. What questions you got for me?
So I had the pleasure of talking with you yesterday in Discord briefly about the concept of mining mercury for the purpose of creating a Dyson satellite system, because I told you I wrote a novel based on that concept. And my biggest, curiosity, I want to be able to pick your brain on how much of the science I got right and how much, I might have invented for the purposes of science fiction. Because I was trying to go for as much hard science rigor as I could, but I'm an English guy, not a physics guy. So one of the things that, and you've already been talking a little bit about some of these concepts already on the show today, so I think this ties in great. But one of the biggest premises of my book was that the reason why they are doing this, the reason why humanity would be focused on this goal, is because of scarcity, because humanity in my story had expanded so much into the solar system that we had exhausted quite a bit of the resources even out there, even beyond our own planet. And that, like, hey, resources are getting scarce, humanity is spreading. Where do we turn to? We turn to the sun. So one of my questions is that even realistic? Is it realistic that humanity would spread into the rest of the solar system to exhaust its resources outwards before turning inwards to the sun?
Is it possible? I mean, sure. Is it plausible? I don't know. It seems like it would be, or
at the very least, what resources would be efficient to harvest?
I have no idea. So I mean, like the reality is that like we can harvest energy from the sun now. Getting to and from another planet or a moon to harvest the resources, you would need some incredible economy of scale or something in order to make that more efficient than just taking those resources and taking the resources that you used to build your rocket or whatever to build solar panels instead. And batteries and the like. It's just not clear to me like look, so as far as fuel is concerned, as far as like energy is concerned, really the only other place in the solar system that we can find like a usable source of energy besides the sun would be like Europa or maybe Titan. One of these moons has like lakes that are made of methane, and you can burn methane. And that would be a really huge resource that we could use as an energy source. You just have to ship it back to the home planet, or you could just use it there and, you know, build a colony there, I guess. The other thing, I guess, is like some sort of like geothermal energy from some of these more active moons that have like more active like volcanism. But other than that, there's not really a whole lot of energy sources that you could use besides the sun. As far as like material resources, like just like metal, the sun's not going to help you there. But the asteroid belt would. The asteroid belt has tons of metal, and it's way easier to get to than Mercury is. So you'd probably start there.
I think that's why the idea of mining Mercury is so appealing, because it's so very close to the source, right? So
it's very hard to get there. It costs way more energy to get to Mercury than it does to get to Jupiter, say.
Right, and in my premise, like the mining base had already been established for 3 years at the point of the story beginning. So like we had already gotten there. That part had already.
It's not the getting. It's the getting there and getting back. Right.
Right.
It's like the taking that resource and bringing it elsewhere. That's the hard thing.
That's the other thing that I never really solved in my process and for the book is like, how is the energy actually being returned? But of course the story ends before we worry about that for reasons. But yeah, no spoilers. Am I allowed to share the title of the book in case people are interested?
Sure.
Okay.
Usually I wouldn't let people shill, but you know, go ahead.
Yeah. I just, you know, it feels, that's why I asked. But the title is The Gate to the Sun. It's available on Amazon. Go check it out, please. The Gate to the Sun by Dave Spaeth. I think it's a wonderful story. But yeah, there were so many things that my limited understanding of the sciences couldn't solve to get to the story. And you know, I had to invent those things, and you know, I was really curious.
It's science fiction. You're allowed to invent things.
Yeah. So, but I was curious, like, how much was invention? How much? And I'm sure a lot of it is. But like, I wanted to get as close to the sciences as I could, at least in my understanding. So
sure. Yeah. I mean, like, so you could engineer a situation where mining Mercury becomes the best option. You know. Like if you need iron, because Mercury is mostly iron and like
iron
nickel
and silicon,
yeah. So like if you need lots of iron, like because maybe you exhausted the entire asteroid belt or something.
Would it be easier to mine iron from the asteroid belt than Mercury?
Yeah. Way easier.
Okay.
It's just easier to get there.
Okay.
So the thing is it turns out that let me look up the escape velocity of the solar system really quick. So the escape velocity of the solar system is 94,000 miles per hour. Now, the orbital velocity of the Earth is 66,000 miles per hour. So we are already 2/3 of the way to escape velocity, right? So if we if we take if we take the speed that we have, we're already moving at 66,000 miles per hour around the sun. You just have to add 20,000 miles, and you could 20,000 miles per hour, and you could basically get to the edges of the solar system. Whereas if you want to drop down to the if you wanted to drop down to the sun, for example, you would have to kill all 66,000 miles per hour. So
okay, that makes sense. So I mean, it's a little counterintuitive because because my thinking was, well, the sun's pulling us, so like, wouldn't that help moving towards Mercury or moving towards the sun if you had the orbits lined up correctly? But I guess what you're saying is the energy to break the speed we're already going would be in that.
Yeah, okay. you basically have to just get that speed in the opposite direction. So you know, you could either increase your speed to 86,000 miles per hour with 20. The unit for space travel that's used to like kind of measure difficulty in getting places is called delta V. It's basically how much speed, how much do you have to change your speed by? So to get from, and actually here's a nice, I just found a nice chart. So to get from Earth to where is Earth? To get from Earth to, say, Jupiter requires... This is in meters per second. What are the units here? Yeah, these are in meters per second, so it's really not that much. So I think it's in... Hold on, let me make sure that this is correct. 1 sec.
Oh, I'm patient.
The delta V to get to Earth orbit is yeah this is in meters per second. So I'll just pull up the diagram so then you can see it. So this is like a delta V map. So if you start at Earth and you want to get to a 250 kilometer orbit, let me move this so other people can see it. It costs 9,256 meters per second of delta V, right? 9,256 meters per second of delta V. And so if you want to get to a geostationary orbit, it's another 2,440. If you want to get to a moon transfer orbit, blah, blah, blah. So basically, imagine that you're starting at Earth orbit, 250 kilometers up, low Earth orbit. You have to add all of these numbers, 2,440, 679, 93 to escape Earth. And then you just follow the chart to see where you want to get to. So if you wanted to get to, say, the biggest asteroid in the solar system, and you wanted to orbit it, or if you wanted to get it, you would do, the 2,440 plus 679 plus 93, so that's like 3,200 or so. And then you would add 388, 923, 379, so that's like another 1,500, so that's 4,600 or so. And then there's and then you need it to enter into orbit, you would need another 4,381 or something like that. So that's like what that was, it was like 3,200, and then like it was like 6,700 meters per second of delta V. Fine, to get to the biggest asteroid in the solar system, and so it would be less to get to other asteroids. But now, in order to get to Mercury, you need the same amount to escape Earth, but then you have to spend just 2,000 meters per second just to get
put a slight
to
pin in
Mercury.
that, because on your chart it mentions Mars transfer, which is a completely different set of numbers. And so what if you're already established on Mars and you're going from Mars?
So if you're going from Mars, you just follow the line down. So you'd start where, start here, say. This is where Mars is. You start here, and then you need 388 to get to Earth's orbit, plus 280 to get to Venus's orbit, plus 2,000 to get to Mercury's orbit. And then you have to do all of this stuff to like orbit Mercury as well. So the point is that number 2,000 is because Mercury is so damn close to the sun.
Right.
Whereas
so you're like
to get
fighting
to Jupiter,
sun's gravity to get into Mercury orbit, right?
It's because Mercury is basically moving so quickly that you have to basically so Mercury orbits the sun far, far faster than the Earth does. Like a year on Mercury is like 80 days or something like that.
Right.
And so
just like
not only do you have to get
a
to
racetrack, the inner circle gets the advantage. Right.
So the point is that like so in order to drop to a lower orbit, you have to slow yourself down. And slowing yourself down costs energy. It's costs the exact same amount of energy as speeding yourself up. So you have to slow yourself down in order to lower your orbit. So you would be moving slower at Earth's orbit, and then you would fall down to Mercury's orbit. And then you would have to slow yourself down even more so that your orbit circularizes with Mercury. And that's what the 2,805 plus 6,310 does to get you to from sharing Earth's orbit to an orbit that is matching Mercury's orbit.
But you did say before, like, getting to those other resources that are not closer to the sun would be
it takes less, way easier.
Takes less. But then conceptually, that means we could have also possibly exhausted it sooner.
Yep, that's
right. So, like,
right, that's possible.
So, like, the idea that this is a last resort, this is a Hail Mary, so to speak, isn't out of the realm of possibility.
Yep. Yeah, absolutely. But like, it's just the kind of thing where you would expect the asteroids would all be mined before you even touch Mercury.
Right. Or at least enough of them that you're already looking what's next.
Yeah, exactly. And I mean, like, even then, it would probably be easier to go to Mars and start, because Mars is covered in iron oxide, right? Start mining Mars for that iron, right? That'd probably be even way easier than than asteroids. Although the asteroids might be easier because actually getting to and from orbit on Mars costs a lot of delta V, whereas getting to and from orbit on these asteroids is not so much.
In my story, somebody who is very obsessed with X's already has laid claim into ownership to Mars.
I see. Well, maybe he has a name of maybe it's Shmilon Tusk.
I wasn't that obvious, but
fair. All right. Well, Red Guardian, I should let you go because there are other people who have questions. But thanks for being here.
This was amazing.
Of course. Take care.
You too.
Oh, I cut him off a little bit early. Let's answer some questions, then we'll bring up another guest. If time is basically based on stars, not like the direct source of creation, but an equation, if two universes collide, does the time change within it? I don't understand that question. Also, I don't even know what it would mean for two universes to collide. From referential recurrence, I actually learned from your... Hold on, I need to pull this up. I actually learned from your channel that the conservation of energy doesn't hold universally. Is there some nonlinear quantity that is conserved universally? No. Well, I mean, angular momentum seems to be. But no, you can't make it like non-linear, and therefore you get something that holds universally. Like you have to have a symmetry in order to have a global conserved quantity. Are molecular orbitals real physical entities or purely mathematical constructs? That's a philosophy question, my guy. All the way that equation could be considered like almost everything that his caller mentioned if it's money being made. Oh, okay. From Binary Ghost with the $10. Universe is shaped like a crumpled paper ball. All that mass knocking around bends space. Gravity causes creases. Effects of dark matter is just us seeing through a fold. This came to me in a dream. Ah, well, if it came to you in a dream, it must be true, right? And from Mr. Kiki with the $2, there and back again, a space miner's tale. That's essentially what they would be doing. They'd be going there and back again. Isn't the limiting factor more from burning stuff and releasing CO2 than available fuel? No, not necessarily. I mean, there's a finite amount of fuel available on the Earth, right? Batteries sent through interplanetary pneumatic tubes, that would cost a lot of energy. A lot of energy. What did Mars be the best option? Isn't that the whole reason why red is filled with... Yeah, well, right. But the point is that like the thing is getting to Mars orbit is easier than getting to asteroids orbit. However, the trouble is that getting like descending down to the surface of Mars, which is what you would have to do, costs a lot of energy because Mars has a lot of gravity. Whereas descending down to, once you're in like an asteroid's orbit, it basically takes nothing to get to the surface. And then once you're at Mars's orbit, now you have to spend energy to extract the iron from the iron oxide. I'm hungry. Where'd I get this diagram? It's from Wikipedia. See? There's a Wikipedia page on Delta V budget. You go to Delta V budget, and then... Why can't I click this? Go to Delta V budget, and then you scroll down. Right there. Great diagram. Of course, these are all optimal like trajectories. They're not going to be, you know, you would always add in some safety factors, right? The Martian Iron Age is going to be brutal. True. Is there any way of physically separating space-time? Separating it from what? How much of chemical reactivity is actually governed by tunneling rather than classical activation barriers? I have no idea. I'm not a chemist. Yeah, it was fruit for thought. The first time they saw two universes collide was not too long ago. We've never seen universes collide. You might be talking about galaxies. Galaxies collide all the time, but galaxies don't control time or anything. Gotta double check something. Oops. All right, let's bring up Ramton. Ramton? How's it going, Ramton?
Hi, nice to meet you.
Likewise. What questions you got for me?
So I had a question regarding the models of gravity in like large scales.
Sure.
So I know, like for example, if you take a look at something like differential equations, if you take a look at like nonlinear differential equations, a lot of the times their behavior changes in the long-term process rather than like a short-term process. So I
Yep.
was wondering, like, is it possible that the effects that we are seeing from what we call dark matter or dark matter, yeah, is actually nonlinear terms in the models of gravity, but because most of the models that we take a look at and we kind of verify is based on like small systems that only has like a few different masses, we don't actually see the effects of these added up until we take a look at something like much bigger like galaxies.
So kind of, but not really. So as far as dark matter is concerned, dark matter doesn't like, so how do I want to say this? The relevant nonlinearities in so Newtonian gravity is linear, general relativity is nonlinear, right? Newtonian gravity is like, it's as nice a theory as you can get. It's just a Poisson equation, which is super linear, super straightforward. The nonlinearities, the deviations from Newtonian gravity in general relativity, the failure to be linear is in some sense captured by a factor, or it kind of like that you can kind of expand away from Newtonian gravity and you get an expansion in 1/c or 1/c squared. So essentially the nonlinearities are suppressed by the speed of light. The faster the speed of light, the smaller the nonlinearities are. And so what is the case is that, and you can just do numerical modeling for this. What is the case is that galaxies, things as large as galaxies and, you know, as diffuse as galaxies, because galaxies are really quite diffuse, they are almost perfectly modeled by strictly Newtonian gravity. And so, and you can just run like you can just run simulations and check that this is the case. Any general relativistic corrections are like minuscule, and so we expect that they behave accordingly, and so it's not really the case that dark matter can be accounted for just by unexplained nonlinearities. At least it can't be accounted for by unexplained nonlinearities coming from general relativity. Now maybe general relativity needs to be modified, and then the resulting low energy, low mass, low speed limit would not be Newtonian gravity, but it'd be some modification of Newtonian gravity, and that might be correct. But if we're assuming GR is true, then GR can't explain dark matter at the galaxy level or larger.
Yeah, that was my guess as well, is that just like how, for example, GR was like more of a correction on like the Newtonian physics, is there potentially a correction on GR that would explain like the effects of gravity that we see on like galaxy scale?
Yes, this is but it's really not even a correction at the GR. It's a correction of Newtonian gravity. This idea is modified Newtonian dynamics, and then the idea is, so you modify your Newtonian gravity, and then you try to come up with some theory that's like GR, that's like in some sense in the same way that GR kind of reproduces Newtonian gravity in you know, kind of like this non-relativistic limit. You would try to come up with a GR-like theory that reproduces your modified Newtonian dynamics in the non-relativistic limit, and that hasn't been particularly successful. And you know, the more data that we collect, the less and less likely this seems. It really does seem like dark matter is like actually stuff, especially because, like, you know, we see gravitational lensing in places where there's not very much matter, which, you know, if it were just a modified Newtonian dynamics, you would just expect that the amount of gravitational lensing would be different. But we see gravitational lensing where we shouldn't see gravitational lensing really at all.
Okay, that makes sense.
Okay.
Yeah, I think that explains the question. I had two other things that I wanted to mention as well. Like, I've been following your content for maybe about a year.
Cool.
And as you kind of mentioned also, like the target audience, like I have a bachelor's in physics as well, but like sometimes when I'm following the explanation that you're doing, the explanation makes sense, but there's a lot of terminology that I'm kind of just lost on as to what they mean, and I feel like that might be crucial. Is it have you ever thought about potentially like putting resources or anything, or like, for example, I talk a lot about like Lie algebra or something, like where to look into so that the terminology potentially makes sense for people?
I mean, I could, but like at the end of the day, what you should do is just Google the words, and like almost everything that I say is going to have a Wikipedia article. Like all of the like the terminology, you could just find it on Wikipedia.
That makes sense.
But like, and the reason why I sometimes use jargon like this is because these are ideas that can't be captured in a short amount of time without that kind of jargon. And so you have to just use the most efficient terminology that you have if you want to make a 3-minute video. The other thing is that, like, you know, it gives people things to look into, right? It's at least in my view, it's better to leave people a little bit confused if they're curious, because then they'll go and do some more learning.
Okay. So like I'm assuming the best way to like look these up are like probably like you as you said, like Wikipedia or something like that.
Yeah, I mean, actually, depending on what I'm talking about, even LLMs can be quite good here, because almost all of the language I'm going to use is going to be very standard. And so this is the kind of stuff that, like, it'll be in textbooks, and so LLMs will scrape those textbooks and will be able to give you a good summary.
Okay.
Just make sure that you ask that it provides you with references, right? Just to make sure that it's not lying to you.
Okay. Yeah, that makes sense. Okay. All right. I think that answers my question.
Cool. Well, thanks for being here, Rampton.
Thank you very much.
Take care.
You.
Oh, I cut him off a little bit early. From Binary Ghosts, one last one for your research funds. Were there any good reasons at the time for the electric universe theory or ether theory? Did the models contemporary to the time support these? So I mean, for the ether theory, yeah. I mean, the idea is that, like, you know, waves are supposed to travel through a medium. The electromagnetic or light is a wave, so it must travel through a medium. Call that the ether, and then you start figuring out how does this ether behave if it's actually like a real thing. Now, as far as the electric universe thing is concerned, I don't think that's not an old thing. I think that that's actually a very recent thing, and it's also super wrong, and there's not really any reason to support it. So yeah, I would say with regards to the ether, probably. With regards to the electric universe, no. Let me just double check, make sure I didn't miss any. I know that there are still people in the guest box, but we are out of time and I need coffee. Does certain particular energy ride on waves that correlates with the color spectrum? So light waves with different amounts of energy are different colors, if that helps, if that answers your question. Otherwise, I don't understand what your question is. You should get a PO box so we can send you stuff. Maybe I'll think about it. Maybe once I get merch started, I will. But not until then. All right, I'm going to end the live stream here. I will be back tomorrow for some more debates, but thank you guys so much for watching, for asking questions, for supporting me. Remember, if you want to participate and ask questions in this part of the live stream, the second hour and a half, the second half of every Ask a Physicist, make sure that you become a $5 a month member. It's like you can do this on TikTok or on YouTube or on Twitch, and then you will be able to participate. Otherwise, you can just ask questions over voice, but nobody wants to do that. All right, until then, I will see you guys tomorrow with some more debates.